Yeah, hi guys, very good morning everyone. Welcome once again to Om Institute and welcome to this session, a power revision session of control systems. A power revision session of control systems. We are going to revise, okay, almost all areas, especially definitely important areas of control system, and we are going to revise it, okay, through the help of 50 important questions. See now, because exam for you, the APGENCO TRANSCO DISCOMS APEE exam is very near. Okay, it's almost 2 weeks or little less than that. So the point is here, question practice is more crucial. But yes, revising through question practice will even help you. Okay, to review important concepts, right? Okay, right. Hi Narendra Babu. Hi Shravandu. Hi Surendra Nayak, hi Tharun Rocks, very good morning to all of you. Come on, you can update all your friends that the session is live. You can share the session. Let's get started guys, okay? Because yeah, we have to do many questions today, 50 questions in a single session. So let's get started, immediately. Before I get started, okay, it's the Independence month, it's the Independence week coming up next Saturday, Independence Day. So on the occasion of Independence Day, the Om Institute has announced a flat 15% discount. Okay, a flat 15% discount on all the GATE, AEE online courses. So all the online courses, including live as well as pre-recorded courses. Okay, if you enroll till 16th of August, okay, using the code Freedom15. Okay, just have to use the code Freedom15 and you can enroll to any of our online courses, be it GATE or AEE, be it live GATE or be it recorded course. Okay, so you can celebrate your freedom by investing in your future, because once you make your future secure, once you become self-dependent, okay, that is where, okay, your true freedom comes for you, right? Yeah. Yes, very good morning all of you. Good morning Vimla. Good evening Parimala Guram. Good morning Arun Kumar. Good morning Indira. All right. Yeah. So guys, the first question for you. Now the first set of questions, okay, looking the nature of your exam, okay, is about what? Is about basic, Laplace or closed loop, open loop transfer function type of questions. Okay, let's get started with a simple question here. What is the inverse Laplace transform for this HS given? S plus 3 upon S square plus 2S plus 1 for t greater than equal to 0. Okay. Yeah, let's get started. Meanwhile, you keep solving. Okay, now I'll suggest you, because I'll suggest you one thing. When you see a question on screen, okay, and most of you might have done your preparation by this time, because I told you exam is roughly less than 2 weeks away for you. So by looking into question, if you get the feeling, yes, this is solvable, maybe I'll be able to solve it quickly. Okay, you can pause my video, you can solve it, and then you can match your answer. Okay, I'll keep continuing with question and solution because there are 50 questions. Okay, so I'll continue in a flow itself, but yeah, you can take, if you know you can solve it, you can take a pause and you can solve, and then you can resume once you're done so that you can match your answer. So what is this HS actually corresponding to? Okay, this is S plus 3. Now if I look into the denominator, S square plus 2S plus 1. S square plus 2S plus 1 is nothing but S plus 1 whole square. Okay, and because I have a S plus 1 whole square, I'll try to, split the numerator also as S plus 1 and then plus 2. Okay, divided by S plus 1 whole square. So definitely, if I now cancel out, okay, the first term S plus 1 will cancel out here. So what does HS look like now? HS will now look like first term 1 upon S plus 1, because one factor cancelled, and the second term is 2 upon S plus 1 whole square. Okay, 2 upon S plus 1 whole square. Okay, now what is going to be HT? Inverse Laplace transform. Okay, so inverse Laplace transform, we generally don't apply any formula. Na? We just try to recall whose Laplace transform is this. We remember it as pair. Okay, now along with the question, whatever are important formulas for you to review, I have got that also in the PPT. Okay, so some important Laplace transform pair. What is going to be used in this question? See, you have two terms here, 1 upon S plus 1 and 1 upon 2 is constant, but 1 upon S plus 1 whole square, and they correspond to the Laplace transforms written here. For 1 upon S plus 1, inverse Laplace will be e power minus 8t, and for 1 upon S plus 1 square, it will be t e power minus 80, S plus a whole square, right? Okay, so all important Laplace transform which will be used, okay, in control systems normally, okay, which you should know, that also I have got it, so that not only you have questions in today's PDF, I will share you today's PDF in Telegram, okay, don't worry about that, but it is that you don't only have the PDF, you also have some, notes for revision, okay, right. So yeah, so what is the inverse Laplace transform here? Let me write down the answer. 1 upon s plus 1 e power minus t, a equal to 1, e power minus at, a is 1, plus 2, 1 upon s plus 1 square, t e power minus at. Okay, so what is the answer? I'll tick mark option number B, 2t e power minus t plus e power minus t. Correct answer is option number B. Okay, yes Arun Kumar, yes Indira, correct answer. Option number B is the correct answer. Okay, next question. Moving ahead to the next question. Okay, so all these you must be knowing, but still this is a review slide for Laplace transform pair. Unit step will also keep coming commonly, Laplace 1 by s, because if I put a0 I get 1 here, unit step. If I put a0 I'll get t, okay, also known as the ramp signal. Okay, all of these formulas by default for t greater than equal to 0. So ramp Laplace 1 by s square. Okay, then there may be any t power n type of question coming, t cube or t power 4 Laplace factorial n upon s power n plus 1. Okay, cos and sine again they will keep coming commonly, for cos omega t s square plus omega square, for sine omega upon s square plus omega square. Okay, now damped sinusoids also I have included. Okay, whenever you multiply any signal by exponential term, the s shifting will happen. So in both the formula you can just replace s by s plus a, wherever s is there, s to be replaced by s plus a whenever you multiply e power minus at. Okay. Chalo, next question for you. A unity feedback system has the following unit impulse response. What is the open loop transfer function of the system? What is the open loop transfer function of the system? Okay, a unity feedback system has this transfer function. Let's do it now. Okay, now a unity feedback system has the following impulse response given, unit impulse response. Okay, right. A unit impulse response is response to unit impulse input, but the important point is, when you take the Laplace transform of unit impulse response, you get the transfer function of the system. Impulse response and transfer function are Laplace transform pair. So you will get the transfer function of the system, right? Unit impulse response. Yeah. Okay. So now the system is unity feedback. Now the system is what? System is unity feedback system. Correct, na? Okay. So what is the transfer function? So take its Laplace transform. Take its Laplace transform. Okay, the transfer function for the that I will write down is going to be, okay, is going to be 3 e power minus 2t 1 upon s plus 2 using the same formulas, minus 2t e power minus 2t, okay, e power minus 2t 1 upon s 2 whole square. Okay, we can simplify this a bit. We can simplify this one a bit. Okay, so what is the transfer function of the system? Okay, transfer function of the system will become, if I take s plus 2 whole square as the denominator, okay, so numerator 3, I'll have to multiply s plus 2 and minus of 2. Okay, so overall this will look like 3s plus 3 to 6 minus 2, okay, will become plus 4 upon s plus 2 whole square. But your story doesn't stop here. Your story is not going to stop here, because this is the transfer function. I need the open loop transfer function. I need what? Open loop transfer function. Now, when I say transfer function is obtained, you know that for a closed loop system, transfer function T of S, okay, is given by Gs upon 1 plus GSHS. Okay, okay, but if it is unity feedback, okay, that means feedback gain is 1. Okay, then the transfer function I'll only write G upon 1 plus G, isn't it? The transfer function will be G upon 1 plus G. Now sometimes G may be given, you want T. Okay, right now I want G. Open. See, actually this is the closed loop transfer function, correct na? This is my closed loop transfer function. Okay, out of which open loop transfer function is normally defined as GSHS. Okay, GSHS we define as the open loop transfer function, which here will become GS. Okay, if HS equal to 1 under unity feedback. Okay, so because it is unity feedback, I need the open loop transfer functions, mean I need the value of G. Okay, so see, T is equal to G upon 1 plus G. Okay, so from here you can simplify, you will get the G equal to T upon 1 minus T. Okay, or I'll tell you a simple, because this is a repeatedly used calculation, I'll tell you a simple technique. Okay, or you take it like this, the transfer function will be written in some numerator by denominator form. Okay, if you write the transfer function in numerator by denominator form, okay, then you will find the G as numerator, this numerator divided by this denominator minus the numerator. right? Once you simplify, you will get this term. Understood, na? Okay, Indra has the answer A. Okay, so that is what we are supposed to do here. What is the transfer function? I'll rewrite. What is the transfer function I have got here for this question? My transfer function is 3s plus 4 upon s plus 2 whole square. S plus 2 whole square, correct. Then what I told you, what is the G? I need the open loop transfer function, and the open loop transfer function, if I am writing transfer function as n by d, you simply write down numerator upon the denominator minus numerator. So my answer should be 3s plus 4 divided by s plus 2 whole square minus of 3s plus 4. Okay, or you can solve by the formula, up to you, t upon 1 minus t. You can substitute the whole transfer function. It will anyways come up this answer only. Okay, so now let's write down the answer. This becomes 3s plus 4 upon s square plus, when I open, okay, this will become 4s. Okay, 2ab, 4s minus 3s will be s. Okay, and this will become plus 4, b square, and minus 4 cancel. So s square plus s, only this much will be left. Okay, upon s square plus s on cancellation. 3s plus 4 upon s square plus s. Okay, 3s plus 4 upon s, s plus 1. Okay, that is option number A is what we can tick mark here. Hope you got this. Okay, hope you have got this answer. Next question. Right, yes, Indra, correct. A answer being correct here. Next question. The open loop transfer function of a unity feedback, negative feedback system is given. Okay, then what is the closed loop transfer function for k equal to 81? Simple, na? Okay, what is the closed loop transfer function here? Okay, and again it is unity feedback, unity negative feedback. Okay, unity negative feedback. Previous question was also unity negative feedback. It was not mentioned, but if it is not mentioned, we take it as negative feedback only, although technically it should be mentioned, but no problem. Okay, so see here. Okay, what is the closed loop transfer function then? Okay, I need for this question the closed loop transfer function for k equal to 81. Okay, and because it is unity feedback, I just have to write g upon 1 plus g. G upon 1 plus g. Okay, and when we are solving g upon 1 plus g, it will be this time equal to, if I write down g also as some numerator by denominator as is given, then here you will get numerator upon denominator plus numerator. Understood? Now, when you are calculating transfer function from open loop gain g, okay, n upon d plus n will come. Okay, so what is the numerator? Numerator is k. Okay, and we have to find it for k 81. So shall I write the numerator directly 81? Yes, divided by s denominator. Okay, s plus 6, s square plus 6s plus 18. Okay, plus the numerator, which is anyways going to be 81. I'll write it here. Okay, so what is the answer that I am going to get is numerator, which is 81 upon this denominator s into s plus 6 multiplied by s square plus 6s plus 18 plus of 81 plus of the numerator again. Okay, now no need to solve it fully. Okay, no need to solve it fully. You simply identify. Acha, no, one term I will tell you so that you don't have to solve it fully. See, this is going to be 81. Okay, now I can write down this s plus 6 also as s square plus 6s. Okay, little bit I will simplify the denominator, s square plus 6s, s square plus 6s plus 18 and plus 81. Okay, so when I am going to expand this, what are the terms I am going to get? See here, s square, I can rather take this, say s square plus 6, s square plus 6, s square plus 6 whole square. Taking the square of that will be easy. So s square plus 6s whole square will become how much? S power 4. Okay, 36s square. Okay, plus 2ab. Okay, so 2ab will become 12s cube. Okay, plus what? Okay, then 18. Now s square plus 6s into 18. So 18s square. Another s square term, 18s square. Okay, then 6s into 18 will be how much? 108s plus 81. Now see, don't need to solve it fully. That's what I am telling. Which answer will match? Okay, first of all, okay, numerator has to be 81. Okay, and the denominator is a 4th order polynomial. Okay, so it cannot be a denominator cube term. Okay, it has to be 4th order. Numerator is not 1. Okay, so you are left with these choice. Okay, but when you are going to expand, no need to rearrange further. Okay, always when you expand s plus 2 power 4, there will be a 2 power 4 term coming up here, and here it will give a 3 power 4 term. Because I am getting the constant term as 81, which is 3 power 4. Okay, so definitely answer will match as A option. Answer that will match as A option. No need to waste your time in recollecting and proving that this is s plus 3 power 4. Okay, right, A answer only will come up. A answer only will come up, right? Correct. Okay, correct Indra, correct Yadav, correct Arvind, correct Yugandhar, correct Arun Kumar, all correct. Hi Surya Teja. Okay, option number A very correct here. Okay, let's go to the next question. Number 4. A unity feedback system has the open loop transfer function Gs equal to k by s plus 6. If the closed loop poles are located at -3 plus minus j4, okay, then what is the value of k? Okay, if the closed loop poles are located at -3 plus minus j4. So see, basic, closed loop poles question, okay, located at -3 plus minus j4. Okay, now closed loop poles, if you want you can form the transfer function, but closed loop poles, okay, normally always write down closed loop poles as roots of characteristic equation. Characteristic equation will always be written as 1 plus loop gain equal to 0, 1 plus GSHS equal to 0. Okay, open loop transfer function given here is only equal to GS, because again it is a unity feedback case. Okay, negative feedback will assume by default if it is not mentioned. Okay. Okay, so what it will be, the characteristic equation will be 1 plus k upon s plus 6 equal to 0. Okay, that means s square plus 6s plus k equal to 0. Okay, right. Now see, how you can solve this. If you want, you can solve it by equations, or if you want, you can compare with the standard second order system. Okay, but let's not compare with any system. We can simply solve it as a logical question, as a equation question, because okay, this particular factor has to be minus sum of roots, and this will come actually also when you add both the roots. This j4 minus j4 cancel, -3 minus 6, minus of minus 6 will be plus 6. But what is k? The question is k, and that in quadratic equation, this last constant factor is nothing but product of roots. Okay, so what is my k answer? My k answer is -3 plus j4 to be multiplied by -3 minus j4. Okay, and when you multiply a plus b, a minus b, a square, 3 minus 3 square is 9. Okay, minus b square, but this j square will become -1. So minus plus. Okay, 16, 4 square 16, 9 plus 16, option number A 25. Option number A 25. Okay. Yeah, Surendra Babu, A correct. Right. It will be A. Okay. Check it out all. It's going to be A as the answer. Next question then. Let us move ahead to the next question. A closed loop system is subjected to unit step input and the response is given. What is the closed loop transfer function? What is going to be the closed loop transfer function? Okay. Now see here. Okay. How do you approach this? Okay. Simply use the basic definition of transfer function. Okay, what is the transfer function? Transfer function, okay, I told you it is the Laplace transform of impulse response, but one more primary definition of transfer function is it is the ratio of output Laplace transform to the input Laplace transform. It is the ratio of the output Laplace transform to the input Laplace transform. Okay, right. So, it's subjected to what input? Unit step input. Okay, so what is the input Laplace? Okay, what is the Laplace transform of the input is 1 by s. Okay, what is the Laplace transform of the output? That I will figure out. Okay, see, if I take the Laplace transform of output, it will become 1. 1 is again like step with both individually. E power minus t cos t, cos omega t. Okay, and e power minus t multiplied s plus 1 upon s plus 1 whole square plus omega square. Okay, omega is 1. Okay, here also omega 1, but how do you write down the sine Laplace transform? Okay, omega, that is 1 upon, normally you write for sine s square plus omega square, but again because e power minus t multiplied, to replace s by s plus 1. Plus 1 square, understood na? Okay, chalo. Now let's simplify and write down the answer. Okay, let us simplify and write down the answer. So what is CS going to become? Okay, or let's write down CS by RS only. Let's try to write down together, and that will become the closed loop transfer function of the system. Okay, CS is 1 by S minus of, okay, how much is this whole denominator? S plus 1 square plus 1 square. So S square plus 2S, okay, plus 2AB plus B square. Okay, again 1 square, again 1 square. So I'll write down total 2. Now come to numerator, S plus 1 plus 1. So numerator will be S plus 2. Okay, whole divided by 1 by S. Okay, now let me simplify this numerator. Okay, if I take whole as S square plus 2S plus 2, okay, then this S square plus 2S plus 2 multiplied here minus S multiplied here, so minus S square and minus 2S whole divided by 1 by S. Okay, so what is clearly cancelled? This S and S term. Okay, this 1 by S of both numerator denominator cancel. My final answer is going to be S square cancel, 2S cancel, only 2 left, 2 upon S square plus 2S plus 2. 2 upon S square plus 2S plus 2. A answer is the correct answer. A answer is the correct answer. A is the very correct answer. It has to be A. Okay. Yeah, Vashishta Arya correct. Answer A is matching up. Answer A is matching up. Others you can correct if there is any error. Yes, yes, yes. Correct. Surya Teja. A answer clearly matching up. Purushottam correct. A answer. Correct. All correct. For the block diagram shown in the figure, find the transfer function y by r. Okay. Find the transfer function y by r. Okay. Now, for such case, I will show you two different methods. Okay. For such case, I will show you two different methods. Okay. How to deal with this transfer function. Okay. Method number one, you can clearly, solve by, block diagram, or you can find out the loops. You can solve it as a graph question also. Okay. Because if you want, okay, method number one, this is my first forward path, input to output. Okay, which contains only the gain 3. Okay, I have another forward path here. Okay, so let this be neat and clean. Okay, I'll come and solve up here. Yeah, please come up here. So, method number one, you see here, I go from here, this is my first forward path. Okay, that corresponds to the gain 3. Second forward path, input to output. Okay, this is reverse, so this is all contributing forward path. The second forward path will be 2, and another gain coming here is 1 by S. So 2 by S, both will multiply. Okay, and there is clearly one loop here. Okay, and this makes a loop. Okay, this makes a loop having the loop gain L1 equal to 1 by S into plus 1. Okay, 1 by S into plus 1. So 1 by S, which is 1 by S only. Okay, positive feedback is given here. Correct. Right. Now, acha, if I erase any of the forward path, okay, suppose I erase this node will go away, or if I erase this also, then this entire branch will go away. Means in either case, the loop will be open. In either case, your loop will be open. Okay, so path factors will be 1. Okay, right. Yeah, that's what I'm trying to do. Just I'm applying the Mason's gain formula, and I'll tell you one more simple thing also. Okay, Vashishta, I'll tell you one more simple thing also. So that is what, yeah, I'll show you. This is what I'm trying to actually apply here. If you come here, okay, this is what I'm actually trying to apply. Mason's gain formula, from which you calculate C by R as summation Pk del K divided by delta K. Okay, the summation Pk del K divided by delta. Okay, Pk is the forward path gain of kth forward path. Okay, right, and delta is the overall graph determinant. How do you take the overall graph determinant? 1 minus sum of all the loop gains. Okay, plus, okay, you take the sum of loop gain product if there are non-touching loop pairs. Similarly, if there are non-touching loop triplets, so you take the product of the triplets, and it will be minus 1. See, plus minus will keep alternating. What is delta K? Path factor, and path factor is nothing but graph determinant of the remaining graph. Which remaining graph? Okay, the graph obtained after deleting the particular forward path. Okay, That is what I am trying to apply, and then I am telling you, for simpler block diagrams, I always go for another approach also. I will show you that. Okay. So how I can solve this here? Okay. So now I will write down C by R, okay, or Y by R here. Output is named as Y. No problem. Any name can be there. So here it is. Okay. So my Y by R will become how many forward paths I have shown you? So summation will be for two terms, two forward paths, P1 del 1 divided by delta. Okay, P1 and P2 written. What is delta? Delta is 1 minus sum of all the loop gains, but this is a simple graph, only one loop is there. Okay, and that too I told you, if I erase the first forward path and second forward path, okay, in both the case loop will be open. Okay, and if there is no loop, what is going to be the delta? If there is no loop, the delta will always be 1. Okay, that means both the delta 1, delta 2 will be 1 here. So my answer will be, okay, I'll substitute the data here directly. Okay, what is the P1 is 3, delta 1, 1. Any confusion, please specify. Then 2 by S into 1 divided by delta 1 minus loop gain. Okay, and the loop gain is 1 by S. That's it. Multiply throughout by S, you get 3S plus 2 divided by S minus 1. 3S plus 2 is divided by S minus 1. Okay, 3S plus 2 divided by the S minus 1, and the answer is option number B. 3S plus 2 is divided by the S minus 1. Option number B is the correct answer. Okay. 3S plus 2 divided by the S minus 1. Next question then. Okay, let's move ahead to the next question. Okay, acha, no. For the same thing, I'll tell you another method. I'm telling you, answer is B, that is okay. Okay. Sometimes, especially for simpler block diagram, no need to count any loops or forward path. If you just write down the flow of equation, you will get your answer. Okay, easily you will get your answer. See here. Okay, this is R. Okay, what I get here is 3R. Okay, this is 2R. Okay, this is directly 1. Okay, so what comes here is Y. So the point is, what is the output equation? One of the part of output is 3R. Okay, and then what is coming here? If you write down this, your output equation is ready. What comes up here? What is the output of any block? Input into gain. Okay, what is the output of any block is input into gain. Correct. Now, what is the input to this block? 2R from here, Y from here. 2R from here, Y from here, multiplied by the gain of the block. Okay, just let me write down there. Okay, so 2R plus Y is multiplied by 1 by S. Okay, when I add these two, I get my total output. Arrange Y on one side, X on one side, done. One line equation it is. Okay, if I bring Y on, every Y on the left side, so this is 1 by S, so 1 minus 1 by S is equal to, take R common, this will be 3 and this will be 2 by S. This is exactly what is written in the Mason's gain structure also. Okay, so when you divide Y by R here, okay, you will get same answer, 3S multiplied by S also, 3S plus 2 upon S minus 1. One line equation can get you your answer. Okay, one line equation will get you your answer. Okay, right? This is what I have done for this question. Okay. Okay, what else? Now see, before I go to, I'll directly for a moment here jump to question number 9, so that I just told you Mason's gain formula, na? Okay, I just want to elaborate more on the graph determinant. See this question number 9. Okay, what is the total number of feedback loops of the signal flow graph? Okay, where R is the input and C is the output. Okay, I am asking you only the total number of feedback loops. Okay, the total number of feedback loops possible. Tell me. Okay, okay. Good to know that, Vashishtha. Yeah, that's what. Second method, these equations, for many places it will save your time. Okay, for many places that equation method will save your time. Now here I am asking the number of loops. Okay, count carefully and tell me. The number of loops, count carefully, specifically, and tell me the answer. Yeah, the number of feedback loops of the given signal flow graph where R is the input, C is the output. Let's count, everybody. Ready? Let's count. If you have counted, please let me know. See here, this is very clearly a loop number 1. Okay, self loop. Okay, whose gain is 12. I'll keep writing the gain also. Then I see another loop here. Okay, this is 1. Okay, then I see another loop here. Okay, this is loop number 2. Okay, 10 into 9. Okay, this is with the flow of arrow. You always follow the flow of arrow. Okay, so this is the second loop. Okay, this is the second loop. Okay, acha, one more self loop I see. I highlight here. Okay, this is also a self loop and this gain is 13. Okay, number 3. Okay, number 3. Any other? One more very clearly I see. This is another loop. Okay, I'll call this as L4. Okay, how much? 6 and 7. 6 into 7. Okay, anything else? Okay, some of you telling answer as 3, some of you telling answer as C, that is 5. Okay, okay, let's check it out. Okay, fourth I have got. Now see here, please. Here, 4, 5 and coming back through 7. Is the loop complete? Yes, it is complete. Okay, so I'll call it as L5. I'll call this one as L5 and this is equal to 4 into 5. Okay, into 7. 4 into 5 into 7. Okay, yes, correct. So this is your loop number 5. Okay, any other loop if you have, you let me know, because answer would be 5. Okay, but if you have anything, if you are counting extra, there will definitely be some error. I can help you correct your error, but you have to tell me what is your 6th loop. Correct answer will be 5 only. Acha, now the question is done. Okay, as far as this question was there, yeah, definitely this is a possible question, because they keep asking number of loops and etc. as a direct question, number of loops or only graph determinant or etc. Okay, now let me tell you, okay, can you find out for me what are the non-touching loop pairs? What are going to be non-touching loop pairs? Can you help me find out this one? What is going to be the non-touching loop pairs? Come on. Non-touching loop pairs. Tell me. L1, L3. Okay, what are non-touching? Let me keep writing here. Okay, and how many? Then I'll see. See, L1 and L2 are touching, but L1 with L3 is not touching. Okay, L1 with L4 also not touching. Sorry, this was L5, but L1, L4 also not touching. So L1, L4 and L1, L5 also. Okay. Now see L2. Okay, L2, L1 touching. L2 and this, what is this? L5. L2 and L5 is touching, but L2 is still isolated with this, isolated with this. Okay. So L2 is not touching to L3 also. This is L2, L3. L2 is not touching to this L4 also. Okay, L2 analysis done. Now L3. Okay, L3, L1 and L3, L2 are already written there. Okay, L3 is touching both L4 and L5. Gone. L4 is touching with L5. Gone. L5. Okay, all are checked. 5. Okay, 5 non-touching loop pairs. 5, 5, 5. Right. 4, you are telling Lucky, no, it's going to be 5. Any doubts here? Any doubts here? Yeah, PDF will be shared in my Telegram group. Don't worry. PDF will be given to you, but PDF will have a password as always. That's my simple rule. Okay. Password will be told in the session only. Okay. Basically, those who are, in the class, they need the notes. Simple rule. So if you are in the class, you will get the password. Yeah. 5 non-touching loop pairs. Okay. Tell me if there is anything you want to mention. Okay. It's 5 non-touching loop pairs very, very clearly. Okay. Yeah. No non-touching loop triplet. Okay. No non-touching loop triplet. Okay. Do you see any triplet? No. L1, L3 are non-touching, but L3 touching these two. L1 touching L2. Okay. So no, there are no 3 loops which I can find which are non-touching to each other. No triplet possible here. Okay, so if I asked you graph determinant now, just elaborating the Mason's gain formula again. If I asked you the graph determinant now, okay, delta 1 minus, okay, sum of loop gains. Okay, that is the first term. How many loops I had? 5 loops. And then plus product, okay, if there are non-touching pairs like L1, L3, L1, L4, L1, L5, and there is one more I told, 2 more, L2, L3, and the last one is L2 with L4. 5 are there. Okay, 5 non-touching pairs are there. Okay, everybody, this is what is the delta. Okay, so what is going to be the delta answer? Okay, let's write down. Okay, let's complete this calculation. L1 is 12, L2 is 90, 12 and 90, and L3 is how much? L3 is 13. Okay, L4 is how much? L4 is 42 and this will become 27. This is not 20 now. Yeah, so this is going to be 140, correct? Yeah. 140 and this was 42. So this one is 42, this one is 140. Okay, plus here product L1 L3 product. Okay, 30. So it will become a bit lengthy calculation. You complete on your own. Yeah, leave it. Let's not waste time in calculation. Okay, let's not waste time in calculation. If you want, you complete. This is the expression I wanted to give you. If you know this, okay, calculation you can handle. That much I can trust you. Okay, let's not waste time here. Let's rather learn more things. Okay, non-touching Lokesh. Non-touching pairs you are identifying. See, non-touching means they are isolated. They are not having any common node or any common branch. You see here, Lokesh, just follow with me here. Okay, if I show you this one, please see. Okay, this is L1. Okay, this is L2. Are they touching? You see clearly they are touching here, na? They are touching here. Okay, that is why L1 and L2 not written there. Okay, L1, L2 not written there. Okay, acha. But this is L1 and this is L3. Are they touching? No, they are not touching each other. So that is written. Okay, what is L4? This is L4. Are they touching? Not touching. So that is how we found the non-touching loop pairs. Okay, correct. Indra, delta 1, delta 2 you write. Okay. Telegram link I will share. Don't worry. Don't worry about Telegram link. That I will share somewhere in between also. Indra, delta 1. Suppose any particular forward path is there. I'll choose one forward path and I'll explain you. Okay. See, Indra, suppose this is my forward path. It will have again multiple forward paths. Suppose this is one forward path. I'll explain you the delta. Suppose this is your forward path P1. Okay. But when I erase it, okay, whatever is the determinant of remaining graph, that you have to write. Determinant of remaining graph you have to write. Understood? Now, when you erase it, okay, you see, okay, this node gone, L2 will be open. Okay. Now, this entire branch gone. This was the branch of L5 gone. This node also gone. When I remove a particular forward path, its particular node will also be gone. And if this node gone, L4 will also be open. L3 also open. But still there is one loop left. Still there is one loop left and that is L1. Okay, so if this is P1, what is going to be delta 1 is 1 minus, how do you write graph determinant formula? You write the same way, but graph determinant of remaining graph. Remaining graph, if there are loops left, how many loop left? So 1 minus L1. That's it. That's it. Hope this is understood. Okay, is that understood, Indra? Similarly, we have to do it for every forward path. Next question now. Okay, so this was on the graph determinant calculation. Okay, I directly jump to 8, the 9th question. Sometimes, like I told you, they are asking only forward paths. The number of forward paths. The number of forward paths. Easy one. This one is easy. The number of forward paths in the following signal flow graph. Just tell the number of forward paths in the following signal flow graph, in this given signal flow graph. Okay, see, forward path is any path from input to the output, no? Okay, so input here, of course, will be Y1 and output will be the last node that I take is Y5. Y1 to Y5, how many forward paths are possible? Okay, how many forward paths are possible? This is one clear forward path, A, D, F, H. Okay, horizontal one. Okay, I'll write down here. Okay, A, D, F, H. Okay, second forward path, and you have to flow. You have to, go in the flow. I mean, in the direction of arrows. Okay, you can't violate arrows. Okay, another one possible here is E and H. Okay, that is E and H. Above one and then going through H. Second also done. Okay, second also done. Okay, anything else? Now see here, I'll remove this. Okay, I go from A, I go from D, and then I take the bottom path through G. I'm going in the direction of arrow, no problem. Okay, so I have a third forward path also, A and D and G. A and D and G. What else? Okay, what else? Now see, very, very clearly you should know that this cannot contribute to forward path because this is in the reverse direction. Okay, you cannot take self loop also because, okay, some of you say this also as the forward path like this. Okay, but this is wrong because when you do this way, listen to me, you come to Y2, you again come to Y2 and then go. In between, repetition of nodes not allowed. in between the repetition of nodes not allowed. Okay, so only 3 will be the answer. Okay, correct answer here will be 3 only. Okay, everybody, correct answer will be 3 only. Next question, number 7. I think 6 we were done. Okay, yeah, now 7. Again, block diagram. So as I told you in the 6th question, which was on block diagram, I have solved by the Mason's gain formula also, counting the loop and forward path. But I did one very simple thing, that is equation, and that helped me get the answer very easily. Look into this question. In the following block diagram, R and D are two inputs. Okay, the output YS, normally, you know, these terms R and D they have used because sometimes there is an external input that we apply and there is a disturbance that may affect the system at some point. D is the disturbance input. Okay, D is the disturbance input. Okay, what is the output? Output is written as G1 into R plus G2 into D. What is G1 and G2? Okay, what is G1 and G2? Surendra, tell me what is the fourth one. I'll help you. I'll then see it is right or wrong. If it is wrong, why it is wrong, I'll tell you. Please mention only the fourth loop gain you mentioned. Fourth forward path gain. Sorry, not loop gain. If you mention Surendra, I'll help you in assessing it. Okay. So let's come up here. Okay, very simply, if I just convert this into equation, I don't have to do anything. Okay, because or either you can use a closed loop formula, but not required. See, this y directly comes up here. Okay, this y goes here, so this will be hy. Okay, input into gain. Okay, so what is coming up here? Okay, here I will get r minus y. In a single line, I will solve both the cases. Okay, this is r minus y. Okay, further it will be added with this. Okay, so what I am getting here is r minus y plus d and minus hy. Minus hy. When I multiply by g, I get my output y. So my equation is ready. My output y will be equal to this equation, r minus y plus d minus hy is whole multiplied by g. Okay, this is whole multiplied by g. Okay, so what is y? If I try to bring all the y terms on the left side, so 1 plus g and this will be plus gh is equal to r into g plus d into g. Is that okay? Is that okay? Yeah, I'll go back to previous question, Surendra. Just a minute, let me complete this. Understood, na? Okay, so I took y here, this is r minus y, this will be added with the disturbance input. Okay, this minus hy coming in negative feedback. Okay, when I multiply this whole by g, that is my output equation. Now, y I am bringing on the left side, so this is 1. Okay, this is minus g, on the left side it becomes plus g, this is minus gh, left side it becomes gh. Then what is left? rg plus dg. Done. My question is done. What is y? Y is now equal to g upon 1 plus g plus gh, separating it clearly, into r plus g upon 1 plus g plus gh multiplied by d. Question told you write down output as g1 into r. Okay, some function g1 into r plus some function g2 into d. What is g1, g2? You can compare. Both are same actually. G upon 1 plus g plus gh. G upon 1 plus g plus gh. Option number A. Both are same, only g upon 1 plus g plus gh. Very simple when I write equation, especially for a smaller block diagram given. Okay, as I told you how we simplified the 6th question also in less time. If I write the equation, same thing I have applied here. Same thing I have applied here, right? Okay, next question now. Okay. Surendra had one more answer here. Let's check that. Surendra is telling ECDG. E. Okay, see E, C, D, actually correct. So this is my mistake. I am so sorry. This is actually correct. Okay, actually it is correct. I am sorry. I'll show to everybody. Okay, answer will be 4. Sorry, that's my mistake. Answer will be 4 only. I'll write down another forward path P4, and that is going to be. I'll show it to everybody. Okay, so very good, Surendra. Okay, see E, C. Okay, D and G. Did I repeat any node in between? Did I repeat any node in between? No. Okay, no. I did not repeat any node in between. Okay, I did not repeat any node in between. Y1 to Y4, Y4 to Y2, Y2 to Y3, Y3 to Y5. Okay, and everything is in the direction of arrows. Everything has been taken in the direction of arrows, right? So I'll write down here E, C, D and G. Answer will be 4. Okay, sorry for my mistake. Okay, but yeah, good observation. That's what, guys. You have to be alert in the class also rather than only following. Okay. Yeah, correct answer. Yes, Indra, it is possible. Right. Okay, so this one will be 4. I corrected it. Number of forward paths. Okay, this was anyways done. 9th question done. Now, question number 10. A basic question here again. The damping ratio and undamped natural frequency, okay, that is zeta and omega n, okay. What are zeta and omega n for the question? Simple question it is, okay, but a simple and possible question. See, all questions that are, possible and expected at your AP AEE exam level, okay, that level only I am considering. Right. Chalo. So, always if the question is around zeta and omega n, try to work out on characteristic equation. And what is the characteristic equation for which I'll need the overall forward path and feedback path? Okay, overall the HS is unity. Okay, but can I find the gain of this loop first of all? What is the gain of this loop? Okay, the gain of this loop will become, okay, the gain of this loop will become 10 by S, okay, and unity feedback, na? Okay, so 10 upon 10 plus S it will come. Okay, or I'll write S plus 10. So, numerator upon denominator plus numerator. Okay, because unity feedback is there, correct? Now, this will be further cascaded with 10 by S. Okay, so for the overall block, this will become my G. Okay, overall forward path gain, and the feedback gain is anyways unity. Okay, so what is my characteristic equation? I'll start by writing the characteristic equation for the system. Characteristic equation, normally as I told you, we write 1 plus GSHS equal to 0. Final HS is unity. So, only that GS, and GS is the cascade of these two, and whenever two systems are cascaded, their gains are multiplied. Okay, so the overall gain will be multiplied 10 upon S plus 10, 10 upon S plus 10 to be multiplied by 10 by S. Okay, to be multiplied by this 10 by S. This is HS. So, this is GS and HS as anyways is unity. Okay, now let's simplify this. Okay, S into S plus 10 I'll take here. So, S into S, S square plus 10S plus 100, 10 into 10, 100. Okay, now, okay, what is this? This is omega n square. Normally, you will compare it to S square plus 2, standard second order characteristic equation, plus 2 zeta omega n S plus omega n square equal to 0. S square plus 2 zeta omega n S plus omega n square equal to 0. You will compare to this. Okay, so omega n square 100, so omega n is 10. This is obtained, and then 2 zeta omega n is 10 here. That is 2 into zeta that I need to find. Omega n 10. This is equal to 10. What is the zeta? 10 cancelled, 1 by 2. Zeta 1 by 2, omega n equal to 10. Option number A is what you can tick mark. Okay. Option number A is what you can tick. Simple one it was, option number A, those who have given is the correct one. Okay, zeta is 1 by 2. Omega n equal to 10. Zeta equal to 1 by 2. If I ask you the nature of response of the system, zeta between 0 to 1, the nature of the response of the system is underdamped. Okay, the nature of the response of the system is underdamped, correct? Next question, number 11. That's what. Which of the following transfer functions of the second order linear time invariant system the underdamped system represented by? Okay, underdamped. Which one will be underdamped? Which one will be underdamped here? You have to tell which one is going to be underdamped here, right? Acha. So for all, if you make one note, okay, if you make one note for all of them, okay, all of them, omega n square is 4, omega n square, omega n square, omega n square, omega n square, the denominator factor. Okay, characteristic equation is fitted where? In denominator, na? Characteristic polynomial. Okay, omega n square 4. Okay, so omega n for all the system is 2. Acha. Okay, now you want underdamped. What I just told about underdamped, zeta less than 1. Okay, simple way to identify rather than calculating zeta for all. Underdamped means zeta is less than 1. Okay, actually zeta between 0 to 1. That should be very specific. Okay, so yeah, all zetas are positive, everything is positive. So let's focus on this condition, zeta less than 1. Okay, so what about 2 zeta omega n? Okay, that should be less than how? So both side I multiplied by 2 omega n. Okay, 2 omega n. Omega n is how much? 2. Okay, that means this 2 zeta omega n factor should be less than 4. That's it. Okay, and where it is less than 4? Option number D. This is equal to 4, this is greater than 4, and this is less than 4. Option number D. Now, if it is exactly equal to 4, okay, if it is exactly equal to 4, for this option you will get zeta 1. When it is exactly 4, this will be equal, zeta equal to 1, critically damped. Critically damped. A answer will be critically damped. For B and C, both of them, zeta will be greater than 1 actually. Okay, because 2 zeta omega n greater than 4, zeta greater than 1. For both B and C, zeta will be greater than 1, right? Okay, zeta greater than 1 represents what? Overdamped. Okay, represents overdamped, right? So for your reference, for your notes, okay, I have got one slide copied for you from my classroom. Okay, that for different zetas, what are the different things you have to remember from which questions might directly come? From which the questions might directly come. Okay, like zeta 0, the response is undamped. Okay, zeta between 0 to 1 underdamped, zeta equal to 1 critically damped, zeta greater than 1 overdamped, zeta less than 0 negatively damped. Okay, just uplift this, negatively damped. Okay, right. Then what are the output expressions? Okay, you have to remember the output expression. Okay, for zeta 0 undamped, 1 minus cos omega nt. For underdamped, 1 minus e power minus alpha t upon under root 1 minus zeta square sin omega dt plus 5. Okay, for zeta equal to 1 critically damped, 1 minus e power minus omega nt into 1 plus omega nt. For overdamped and all, very complicated expressions, so better to handle by Laplace transform. Whatever commonly you have to remember. Okay, stability, or for any positive zeta system is stable, for negative zeta system unstable, and for zeta 0 marginally stable, oscillatory systems. Okay, when I say the response is undamped, I mean oscillatory. The waveform is pure oscillatory. You see, pure sinusoidal function. Okay, right. The nature of poles also I have written. Each of these things, if you remember, okay, high chance a question is there from this slide itself. Okay, directly a question might be there. Okay, either directly from this slide, or if calculations are required, that also formula can be used from this slide. Okay, second order system important for you, no? Okay, second order system important for you. So nature of roots are also I have written. You just go through it. I'm telling you, today's class along with questions, few notes I have included so that you revise. Okay. Okay. Yeah, see, underdamped is still oscillatory, na? Correct, Vashishta, you should know that. Okay, undamped to pure oscillatory. Underdamped is oscillatory but with amplitudes continuously reducing. Okay, critically damped and overdamped are non-oscillatory. Okay, right. This one, so if you have asked this, I'll write down. This one is pure oscillatory. Sustained oscillation. We also say oscillations are sustained in nature. But this is underdamped, means it has still oscillations but which are damped. When I say damped oscillation, what do I mean? When I say damped oscillations, what do I mean? Okay, that the amplitude of oscillation will reduce. Okay, but both of these are non-oscillatory. Critically damped and overdamped are going to be non-oscillatory in nature. Okay, this much you should know. Right. Acha, one more thing for underdamped, few more things if I write down here. Acha, I have one question, I think, let me answer it, let me ask it from you. Okay, then you can answer it. Then I'll write down this. Yeah, this is the question I'm talking to. The third peak overshoot and the second undershoot. Okay, I want to know how many of you know this expression. The third peak overshoot and the second undershoot of the step response of second order underdamped system is given by what formula? Tell me the correct answer. If you know it, you just have to tick mark. Yeah. Tell me. The second peak overshoot, the third peak overshoot and second undershoot. The third peak overshoot. and the second undershoot? Tell me. Okay, common answer coming is A. Anusha has given the answer D. Commonly answer coming is A. A is wrong. A is wrong. A is wrong. A is the wrong answer. You got into a trap. A is the wrong answer. So that's what. Okay. For underdamped system specifically, what are some important formulas that you will remember? Number one, rise time. Okay. Rise time. Okay. Will be given by the formula pi minus phi by omega d. I'm writing in short form pi minus phi by omega d. Okay. Where, okay, you should know what is omega d, damped frequency of oscillation. Omega n under root of 1 minus zeta square. Alpha damping factor is zeta into omega n. Okay. And phi means cos inverse zeta because zeta is written as cos phi. Okay. This is the rise time formula. Okay. Other than rise time, okay, the peak time. First, I will only write down the peak time and overshoot. Okay. Peak time and maximum overshoot. Peak time and maximum overshoot formula. Peak time will be given by the formula pi by omega d and maximum overshoot will be given by the formula e raised to the power minus pi cot phi. Okay, now what is cot phi? Cot phi. What is cos? What is cot? Cos upon sine? Okay, cos phi is zeta, sine phi is 1 minus under root 1 minus cos square theta. Okay, so normally when you fit this, you see the formula written in the book. I write it simply e power minus pi cot phi. For percentage, you can multiply by 100. And next formula that you should know is settling time. Okay, settling time for 98% criteria when the output reaches 98% of the steady state value. Okay, 98% criteria, or we say 2% error, for a 2% error band. Okay, the settling time for underdamped will be given by 4 by zeta omega n. 4 by zeta omega n. Correct, na? This much normally you should remember. Okay, but then overshoots and undershoots. Okay, general undershoots and overshoots. Okay, see, I'll write down a standard formula here. Like peak time, n pi by omega d. Like peak time, I've written pi by omega d. Generally, write down a formula. I'll just call it as T, time formula, n pi by omega d. And write down an overshoot formula. Overshoot or undershoot value. Okay, is normally given by the formula. I'll simply put down this way: e power minus n pi cot phi. But yeah, as I told you, if you put down the value of cot phi, which I have written here, you will write it as e power minus n pi zeta upon under root 1 minus zeta square. Okay, this is undershoot overshoot value, and this is the time for undershoot overshoot. Okay, the point is overshoots will occur, overshoots and undershoots will alternate, na? Okay, overshoots n equal to odd, undershoots n equal to even. N equal to even. That means for overshoots I need to put 1, 3, 5, 7, etc. For undershoots I need to put 2, 4, 6, 8, etc. This is what is the point you should know. Okay, and look into this question. Okay, the third peak overshoot. So what n I will put? Third odd number, not n equal to 3, n equal to 5. In 1, 2, 3. This one, the third odd number. Okay, and second undershoot. Okay, that means 4. That means 4. Okay, that means 4. So that is why the correct answer will be D. Acha, their epsilon here is zeta. Here epsilon, maybe it is mistyped, or it, you know what it is. Okay, it is zeta. Okay, that means 4. So that is why the correct answer. No, voice is totally clear. I just heard it. Soumya Ranjan, the voice is looking clear. Okay, voice, I'll again hear it in here also. Yeah, I think bit of issue is there. I'll just try to check it out. I'll just show you the next question. Okay, just a minute. Yeah, by the time just complete this question. For a feedback system shown below, if KT and KA are given to you, KT is 0, KA is 5, then the steady state error for unit ramp input is 0.2. Okay, it is going to be mixed with the steady state error also. What will be the new value of KT and KA if the damping ratio is increased to 0.5 without affecting the steady state error? Okay, it's actually a question. Okay, it's actually a question. Okay, on a controller, but we can solve it by time response analysis. You don't have to remember any separate formulas. Okay, this is a derivative feedback controller. Okay, this one block that is shown here in front of you is a tachometer, also commonly known as derivative feedback controller. A derivative feedback controller, or commonly the tachometer. The tachometer. Okay, tachometer. Okay, just a minute. Please complete this question by the time. I'll be back in a minute. Yeah, please check now. And if let me continue, and if there is still any issue, please let me know. Okay, okay, Akbar. Yeah. Great to know you are appearing for this exam as well. Okay. Yeah. Let's get the answer. Somebody has given the answer here. Answer is what? B. Okay. Let's check it out then. Okay. For the feedback system shown below, if KT and KA are given, then the steady state error for unit ramp input is 0.2. Acha. Firstly, if I consider this KT and KA equal to KT 0 and KA equal to 5. Okay, under this condition, what it is going to be the case? The first thing is, okay, I'll solve under both the case, and let's copy this twice. Yeah. Okay, first thing they have told is if Ka equal to 5 and Kt equal to 0. That's what I told now. Yeah. Okay. So when Kt is 0, that means there is no roll of this block. There is no roll of this block. Okay. This is gone. Okay. So only forward path gain will be, okay, only the open loop transfer function that is going to be there is Gs. Okay. Unity feedback is there. So I'll write down that Gs and that is going to be Ka. Okay, directly in cascade with this because there is no SKT branch. Okay, gain is 0. So this is 10 by S plus 2. What they told, okay, acha, now can you define the type of the system? I'll come to separate steady state error question also. This also has a steady state error. Okay, now what is the type of the system? The type of this system is type 1. Okay, number of poles of GS at origin. Number of poles of GS at origin when the system is in unity feedback. When the system is in unity feedback, you can note down if there is anything that you don't know, you can note down the definition. Okay, you know, whenever it is S power 1, if it is S power 2, it will become type 2. Whenever, what is the separate S power n? Number of poles of origin of GS when the system is connected in unity feedback. Okay. Yeah, so this is type 1. Now, one thing that you should always know, anyways, we are going to go to the error question also. Okay, one thing that you should anyways know is, you know, this thing. This help you a lot. Okay, right now we are into type 1 system. Okay, right now we are into type 1 system. Okay, and whenever it is type 1, the steady state error for ramp will be finite. Okay, remember this way, type 0, type 1, type 2. It can be any type, but this is the three most commonly most commonly coming in question, type 0, type 1, type 2, and the three common inputs coming, okay, the three common inputs coming is step, ramp and parabolic. Okay, so type 0 will go with step, type 1 with ramp, type 2 with parabolic, means, okay, for this case the error will be finite. Okay, so write down the diagonal element as finite, simple way to remember it. Okay, above diagonal, okay, that means lower order input 0, below diagonal, okay, for the same time, like type 0 with step will give finite. So if I take below diagonal, that means if I take higher order input, okay, the error will be infinity. Okay, higher order input, why I say higher order? Because step is 1 by S, ramp is S square, 1 by S square, and parabolic is 1 by S cube, unit parabolic. Okay. This way you can remember. Acha, what is this finite error? I am telling you for type 1, ramp will give finite error. How much finite error? For ramp, okay, it is given by 1 upon kV. Okay, for step, it is given by 1 upon 1 plus kp, and okay, for type 2 system, parabolic input, okay, will give the finite error. How much finite error? It is given by 1 upon Ka. Okay, now what are this kp, kv and Ka? Okay, kp will be limit of S tending to 0 Gs. Okay, kv, velocity error coefficient, limit S tending to 0 S into Gs, and Ka, okay, limit S tending to 0 S square Gs. Okay, S square Gs. Okay, all this analysis considering stable system. All this analysis is valid considering the stable system, correct? The stable system. Now listen to me. Okay, so yeah, let's go to the previous question. Yeah, so this is type 1 na? Okay, now this is type 1. Okay, the steady state error for ramp is given. Okay, okay, for ramp input, okay, so I know I'll require kV. I will start with kV calculation. kV means limit of S tending to 0 S into Gs. Okay, limit of S tending to 0 S into Gs, S into this value 10 upon S, S plus 2, 10 upon S, S plus 2, S and S cancel, and 10 by 2 will be 5. Okay, so what is the steady state error? 1 by kV, that is 1 by 5, and that is anyways 0.2. They have given 0.2, but that is just a waste data given. We can calculate also. Okay, right, 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 correct. So error anyways is 0.2. Okay, even if that data was not given, but what is important is now what is the new value of Kt and Ka if the damping ratio increased to 0.5 without affecting the steady state error. That is why they have given the new steady state error should also be 0.2. Okay, the new steady state error. Now with everything in picture, what should be the new value of KV and KA and KT? So first of all, dear, I will like to find out this inner loop gain. Okay, this inner loop gain, okay, this would be how much? Okay, G upon, this is G upon 1 plus GH. H here is SKT. So now multiplying S plus 2, what is going to be left is 2 upon S plus 2 plus 2 SKT. So S, if I take whole common, 2 by S plus 2, and here also S common, so 2 KT plus 2 KT. Correct? This is what is, okay, the gain of this inner loop. Now this will be cascaded with KA. So overall GS now. Overall GS, that is going to be, now there is, these two will multiply, so that will be 2KA multiplied because they are in cascade. So this whole multiplied by KA, so 2KA upon S plus 2 plus 2 KT. Now listen to the first thing. Okay, steady state error same is desired to be 0.2, that is the same. Okay, now that means, okay, KV will be 5. Okay, if steady state error same means KV also will be same, that is 5. Okay, that is 5. Now KV is given by, okay, limit S tending to 0, S into GS. So S into GS, again this S will cancel, and now if I put S tending to 0, this S will be 0. So I will get 2KA upon 2 plus 2 KT, this is 5. This is only one equation coming, 2 and 2 will cancel. Okay, KA upon 1 plus KT is equal to 5. Okay, now I want the zeta also. They told, okay, I want the damping ratio to be increased to 0.5. Okay, maybe earlier damping ratio would have been lesser. Okay, don't calculate the earlier. Okay, just whatever is new given. But if it is whenever zeta or omega n is coming, I will write down the characteristic equation. Overall HS is 1, so only overall GS required. Okay, 1 plus 2 KA, this is the GS upon S plus 2 plus 2 KT. This is the characteristic equation. So multiplying this, I'll get S square plus 2 into 1 plus KT multiplied by this S plus 2 KA is equal to 0. Now let's make it simple actually. From here, let us write down KA is equal to 5 into 1 plus KT. From here, KA will become 5 into 1 plus KT. Okay, and I want the zeta. Okay, I want the zeta. Okay, so KA is equal to 5 into 1 plus KT. Everything will come down to KT. Okay, so S square plus twice of 1 plus KT into S plus 2, 5, 10 into 1 plus KT. This much is 0. Okay, so come to this term and you can say that 2 zeta omega n is equal to 2 into 1 plus KT. That means, okay, 2 cancel. Zeta desired is 0.5. Okay, zeta desired is 0.5. Okay, so 2 cancel. Omega n into 0.5, that is 0.5 omega n is 1 plus KT. So what is going to be omega n? Okay, 0.5 divided there, 1 upon 0.5 will be 2. Omega n is 2 into 1 plus KT. Acha, omega n is also obtained from this term. Omega n square is 10 into 1 plus KT. 10 into 1 plus KT. So from here, if I solve, okay, omega n square, if I take the square here, okay, 4 1 plus KT whole square. Omega n square means this one, and this should be 10 times 1 plus KT. Okay, a sort of quadratic equation will come first of all. Okay, right. Yeah, option substitution, anyways you can go, that anyways is there. I'm just trying, see, my intent is to go for your complete conceptual understanding also. If you want option understanding, let's see if the option is matching. Ka should be 5 times 1 plus KT. Ka should be 5 times 1 plus KT. 1 plus KT, 2.5 into 5, no. 2.5 into 5, okay, 1 plus KT, no. Okay, then only option number B will match. That anyways will be there, that everybody can do. Okay, understood. Okay, that's what, see, so if I take this, okay, question finished here, option number B, that's okay, and that you have to do actually, you have to be smart there. Okay, you have to be actually smart there in checking that. Okay, but I'm just trying to explain you the whole procedure. Okay, if they asked only one specific value, then okay, I asked you both KT, K. If I asked you only one value, then you should be ready for everything. Okay, so from here you will have to solve KT now. Okay, from here you will have to solve KT. Yeah, that's what. I'll go with the complete details, but wherever possible, okay, you can do that anyways. Okay. So 2, if I cancel here, this will become 2 and this will become 5. Okay, 2 into now KT square plus 1 plus 2 KT. This will be 5 into 1 plus KT. Now, overall quadratic equation that is going to become is 2 KT square, okay, plus 2 to 4 KT minus 5. So, minus of KT and plus 2 and minus 5 minus 3 equal to 0. Okay. Now, from here you complete your calculation, you will get some value of KT. Okay, what is that KT I will get? I will write down that quickly. The KT part you can calculate. Yeah, so I am getting 1.5 and minus 1. Okay. 1.5 and minus 1, and by default we will take the positive gains only for any block. Okay, so we will not take this negative part. So KT 1.5. Okay, so what will be KA? KA is 5 times 1 plus KT and 2.5 into 5, 12.5. That is KA also. That anyways is option number B. Same thing we got by fully solving it. Okay, 1.5 and 12.5. Okay, 1.5 and 12.5, right? Okay. Vashishta, it seems that you have some doubt in that table. Okay, let me take 2-3 more questions and then elaborate your doubt a little bit better so that I can help you out. Okay. Next question, guys. So this was a question using error and the zeta transient part both. Good question it was. Okay. Question number. We'll come back to it. Let's take the error question. Okay. Let's take the error question here. Okay. Please take up this error question here once again. Everybody, please take up this question. Yeah. Let's do it quickly. The closed loop system shown in the figure where k greater than 0, alpha greater than 0, the steady state error due to ramp input. Acha, now due to ramp input, yeah, intentionally I have taken this question here. Due to ramp input, alpha by s square, okay, what is going to be the steady state error? I told you 1 upon kV is the answer. Okay, when you have unit ramp, okay, this is not unit ramp is 1 by s square. Okay, this is alpha by s square, so error will also multiply by alpha. Error will also multiply by alpha, that you have to take care. Okay, rest what is kV, that you can find out here. kV is same, limit of s tending to 0, s into gs. S into gs, k by s, s plus 2. Okay, s cancel, then put s tending to 0, k by 2. This is k by 2. So final answer, this is alpha upon k by 2, or that is 2 alpha by k. 2 alpha by k, option number A. Option number A. Okay, please check it out. It has to be option number A. Correct answer will be option number A. Done? Okay. Next question. Right. So these formulas, I will be very specific that these formulas in the table that I have shown to you is for unit step, unit ramp, and unit parabolic. Now, what you have to understand, what does this table says that the question is for unit ramp input. Why? Because the system is type 1. Okay, the system is type 1. Okay, why it is type 1? Because there is one pole at origin. Okay, so here if I by chance ask you, they can ask this also. What is the error? Due to step input. Okay, so step is, see, what you should remember that type 1 goes with ramp. Ramp gives finite error. Okay, lower order input. Okay, 0. And if the question is steady state error due to parabolic input, parabolic is higher order than ramp, and higher order means infinity. Infinity. Understood? This is what I meant. Okay, this is what I meant. This is infinity. Okay na? This is infinity. Purushottam, you are telling 1 plus kt directly cancel. Okay, but always remember, yes, you can do that. Okay, but always remember 1 plus kt has to be non-zero for that, which here it will be. Okay, but whenever you are cancelling x from both the side, it has to be non-zero. Yeah, come up here. Next question. Consider the open loop transfer function. Consider the open loop transfer function given here. Okay, GSHS equal to 5s plus 1 upon s square, s plus 5, s plus 12. Okay, and consider unity feedback. Not mentioned, I'll tell you, assume unity feedback. Okay, so what is the type of this system now? Okay, denominator s square. Denominator s square, that means it is type 2. Denominator s square clearly means it is type 2. Okay. That is why the question is coming with respect to parabolic input. They can ask, see, if I ask you the error due to step and ramp, okay, 0, it will be 0, that you should know. Okay, if the question was steady state error due to what? Due to step, 0, due to ramp, 0. Okay, we have to find due to parabolic, and that is given by 1 upon Ka. And what is Ka? Ka is limit s tending to 0, s square into gs. S square into that gs I will place 5 s plus 1 upon s square, s plus 5, s plus 12. Okay, so this s square will cancel, and s tending to 0, 5 into 1 upon 5 into 12. So this is simply 1 by 12. Okay, so reciprocal of Ka will become 12. My answer is option number C. My answer is option number C. Correct. The correct answer is option number C here. Correct answer is option number C. Next question. Unity feedback system has Gs given to you. K s plus 2 upon s, s plus 4, s plus 9. What is the value of K? Okay, to yield 10% error in steady state. Okay, 10% error in steady state. Just a second. Let me check if the data is consistent. Yeah, correct. Right. So 10% error in steady state due to what? 10% error in steady state, of course, because it is type 1. Okay, because it is type 1, one pole at origin. So that is only going to be due to unit ramp input. Not mentioned, but that has to be due to unit ramp only. Right? It has to be unit ramp only. Now see here. Okay, now please see here. Okay, 10% error. Okay, that means steady state error in absolute value is 0.1. Acha, steady state error for ramp input should be 1 upon kV. That means kV has to be taken as 1 upon 0.1, that is 10. Okay, now what is kV is limit s tending to 0, s into gs. Okay, gs is k is going to be divided by s plus 4, s plus 9, and this would be 10. Okay, s and s cancel, k will be, I'm putting s tending to 0, I will have k will be 10 into 4 into 9 divided by 2, and that is 180. 180 will be option number B. Correct, option number B. See, Vashishta, okay, I'll come to that. Answer is B here, correct? For this question it is B. See, what is the difference between error and steady state error, Vashishta? Error, okay, as a standard definition, error is defined as the difference between the reference input and the obtained output. This is RT minus CT, or in S domain, I can write it as RS minus CS. Okay, what do I mean by steady state error? Error at steady state. Okay, error when time becomes large, that is what is ESS. So that is error signal only, but when t tends to infinity. Okay, limit t tending to infinity ET, and that is final value theorem is applied. Okay, final value theorem is applied to write down limit s tending to 0, s into ES. Final value theorem. Okay, this is what is done. Okay, and then error signal has been calculated finally. Okay, solving further, you will get this error signal as R. Okay, on solving the unity feedback block diagram, the error signal you will get as RS divided by 1 plus GS, which is further substituted here, and then based on the type of GS and based on the input, that table has been drawn. Okay, the table has been drawn. Okay. Correct. Which point to be, which point is the doubt you have, Sheikh Ansar? Please repeat your doubt. Okay, please just repeat your doubt. Acha. Now, one question I just skipped in between. Now, let's go. First order system. Okay, very quick answer you can give it to me. Very quick answer you can give it to me. Just a moment. Yeah. Now tell me the answer. Okay. For the system 2 upon s plus 1, what is the approximate time taken? Say your doubt, Sheikh Ansar. I mean, if you specific with doubt, then I can help you. 17 question already done. Now, what is the doubt in 17 question? The approximate time taken for a step response to reach 98%. Now, this is a first order system. Okay. Only thing is, when it is first order system, normally write down as k upon 1 plus st. The k can be any gain, 1 upon time constant will be important here. You know that t is the time constant of the first order system. Time constant of the first order system. Now for first order, two things, if numericals are there, two common formula. Rise time, okay, 2.2 t. Okay, settling time for this 98%, settling time is 4t. Okay, 98% criteria, settling time 4t. Okay, and the next one, this is okay, that I'll take during frequency domain time. In time domain, you remember this much. Okay, 2.2t and 4t. Okay, so for this particular case, what is the time constant is 1 plus s. Okay, 1 plus s. So what is the settling time? Okay, that is 44 seconds. Option number C. Tick mark the answer as option number C. Yeah, that is what I have got here. Okay, option number C. Okay, this is done. 16th done. 17th also done. Yeah, Sheikh, if you can specify your doubts here. Otherwise, it is the same as what I have solved in previous question. Now, this question. In the feedback control system shown in the figure below, GS equal to 6 upon S, S plus 2, S plus 6 upon S, S plus 1, S plus 2, RS, YS, ES are the Laplace transforms of RT, YT, ET. If input is unit step function, if the input is a unit step function, okay, then what is the answer? Then what is the answer? Please tell me. Okay. You can, Indra, you can convert it. I'll just give you the hint. Okay, separately, if I solve, it will take a lot of time here if I take separate doubts. You can mention this doubt in Telegram. I'll give you the hint, Indra. It is the closed loop transfer function given t. In the beginning, we solved, you can calculate g from t. You can calculate g from t. Okay. You can calculate g from t. See, Indra, okay, what you are trying to tell me, I'll tell you the hint here. Okay, t given. Okay, closed loop transfer function t given. Now you have two options. Okay, calculate g as t upon 1 minus t, or I told you another method, numerator upon denominator minus numerator. If you calculate g, Indra, okay, you can solve the question like previous cases, number 1 point, or you can go by, see what I just told you. Okay, error is what? Input minus output. Na? So what is the steady state error? Limit s tending to 0 after final value theorem, s into es. Okay, steady state error is limit s tending to 0, s into es. What is the es? Rs minus cs. R minus C. Okay, but what is output of any system? Input into gain, and gain means transfer function. That is what is given to you t. That is what is given to you t. Okay, so substitute that here. Okay, you can also solve this question as limit of s tending to 0, s into r minus rt, or I'll take r common, 1 minus t. Okay, Indra, you can just complete this question by this formula, you will get your answer. If you don't get, again let me know. Okay. This is the way you can solve it up, or you can calculate G separately. You can calculate the G separately for this question. Okay. You can calculate that G separately for this question. Okay. Any further doubt, please let me know. Yeah. So now here, this question is for a trap. This question is for a trap. See here. Okay. This question is type 1 pole at origin. Okay. Type 1, correct. This is type 1, no doubt. Steady state error due to step input. Because it is type 1, it should give a finite error for ramp. The step is lower order, and due to step, it should give how much answer? It should give 0. Okay, answer B, no. This is a trap. This is a trap. Okay, why it is a trap? Okay, why it is a trap? Now let's understand, and we'll also move towards stability from here. What is the characteristic equation? 1 plus GSHS, 1 plus 6 upon S, S plus 1, S plus 2 equal to 0. Okay, 1 plus 6 upon S, S plus 1, S plus 2 equal to 0. When I simplify this, I'll get S, 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 S cube. Okay, 1 plus 2, 3, S, S square. 1 into 2, 2 into this S, and plus 6 here equal to 0. I whole multiplied here. Okay. Now, this is a cubic equation. If I ask you about the stability of the system, okay, I'll leave this question here. Okay, I'll take a stop, I'll take a halt here. I'll come back to this question because there is something that I have written on that table itself. Okay, this is all the analysis will valid for stable system, because all this analysis comes with the help of final value theorem, which is applicable for stable system. Okay, which is applicable for stable system. Right. Now, okay, this question is a trap. I am telling you, answer will not be B, answer will not be 0. I'll explain you why. Okay, I'll explain you why. Okay, I'll tell you one thing. I'll stop this question here. I'll first take you towards this question. Step by step, we'll discuss stability area. Tell me now. Okay, which of the following statement is correct for the open loop transfer function? Gs equal to Ks plus 3 upon S minus 1. Okay, open loop system stable, closed loop unstable. Tell me this answer. Open loop stable, closed loop unstable. Yes, correct. We will start, online courses. You're looking for GATE online course, Nuna? Are you looking for GATE course or AE course? Which course you're looking for? Tell me. Yeah, everybody, you can solve and tell me the answer now. See, open loop to already given. Open loop to already given. What are the poles of open loop? Okay. Open loop poles. What are the open loop poles? S equal to 0 and 1. Okay, S equal to 0 and 1. But this is right half plane. Okay, RHP pole, so unstable. Open loop to unstable because I directly know the poles. Any system or any transfer function is stable if all poles are in the left half plane. Okay. Any one pole in RHP system unstable. Pair of imaginary poles. Okay, marginally stable. Repeated pair of imaginary poles, again unstable. So open loop unstable because there is a RHP pole. Now for closed loop we need the closed loop poles, but you can find the closed loop transfer function, but always remember closed loop poles are nothing, I told you earlier also, are nothing but roots of characteristic equation. So no need to find the transfer function, directly go for characteristic equation. Okay, 1 plus GSHS 0, this is unity feedback, HS will be 1 here. Okay, so if I write down that characteristic equation here, 1 plus Ks plus 3 upon S into S minus 1 upon S into S minus 1 equal to 0. Okay, so this will become, okay, S square, okay, minus S plus, open the bracket here, Ks plus 3K is equal to 0. Okay, I'll write down here S square plus, okay, K minus 1 into S, I can combine, na? K minus 1 into S plus that 3K is equal to 0. Guys, I think some system error. Why is that so? I'm not able to understand. But okay, looks stable now. Okay, plus 3K is equal to 0. S square plus K minus 1 into S plus 3K equal to 0. Now listen to me, important point. This one is a second order system. Okay, if it is second order system, okay, if it is second order system, no need to go for Rautherwitz, because I have seen people applying Rautherwitz everywhere. Second order you can apply, but not required. Okay, only one thing you should know is, if it is second order system, all coefficients must be of same sign. Okay, plus, plus, plus. If all are of same sign, then the system will be stable. That is the only condition required. That is the only condition required to comment your answer here. No need to go for any Rautherwitz here. Okay, that means number 1, 3K must be positive. Okay, that means K must be positive. And number 2, K minus 1 must be positive. That means K should be greater than 1. So combining both, K should be greater than 0 and K should be greater than 1. So actually K should be greater than 1. So automatically it will be greater than 0. So the system will be stable for K greater than 1. Now the question was asking, okay, for K greater than 1 only. Very good. The question was asking for K greater than 1. Correct. So for K greater than 1, the system will be stable. Closed loop stable, open loop unstable. Open loop unstable, closed loop stable. Tick mark answer B. Tick mark answer number B. Now tell me if there is any confusion. Okay, you can tick mark the answer number B. Okay, you can tick mark here answer number B. If that is okay, tell me. Okay, answer number B. Okay. Now see, all coefficients of same sign for second order system alone is, final condition. No need to apply Rautherwitz. But if it is higher order, okay. But if it is higher order, okay, there are two things you should know. Okay, one is necessary condition. One is necessary condition. All coefficients of same sign. All coefficients must be of same sign. Okay, all coefficients of same sign. Okay, and all present, or okay, and none of them is absent. I'll write this way. All should be present. None of them is absent. This is how I will write. Okay, second. Okay, now this is only the necessary condition. Okay, this is definitely required, but this is not alone sufficient. Sufficient condition is in the form of Routh array. That I will explain. Okay, this is usually for higher order. Okay. Okay, so for higher order, we need to go for Routh array. Okay, we need to go for Routh array. Okay, we need to go for Routh array. Yes, yes, K greater than 1. Correct answer, Sheikh answer. K greater than 1, and the question also told K greater than 1. That means system is stable. Acha. So what I am telling you, for sufficient condition, I'll explain you how to form Routh array. But in higher order also, when I say higher order, means third or more. But whenever it is actually third order, okay, that means when you have a cubic characteristic equation, you can directly apply the shortcut. What is the shortcut? See here. Cubic characteristic equation, as square q plus bs square plus cs plus d equal to 0. Okay, suppose the characteristic equation is as q plus bs square plus cs plus d equal to 0. Okay, for stability, calculate this inner and outer. Okay, I'll call this as inner terms, b and c, and a and d as the outer. Inner minus outer we do. Okay, just do a calculation, inner minus outer. That is b into c minus a into d. Okay, if this is positive, the system would be stable. Okay, If it is 0, the system will be marginally stable, oscillatory system, what I told you. Okay, and if it is less than 0, the system will be unstable. The system will be unstable. Correct. This much is enough for a cubic equation. This one is enough for a cubic equation. Okay. Achha, at the same time, necessary condition says that all ABCD must be positive. That is the first criteria. ABCD, this must be positive. Correct. So if I go back to that error question, first of all, again here, okay, look into this inner minus outer for this error question. 3, 2, and this is 1, 6. 3 minus 2 minus 1 into 6, this is equal to 0, indicating the system is not stable, rather it is marginally stable. Okay, if it is marginally stable, the error is also oscillatory. The steady state error is, okay, oscillatory. Okay, the steady state error cannot be defined because output is oscillatory actually. Okay, so steady state error is also oscillatory. So answer would not be B. For this previous question, answer has to be A. Limit t tending to infinity, okay, does not exist. The error is oscillatory. Steady state error as well as the error is oscillatory. Okay, if you want, I'll write down in the form of error signal only. The error is oscillatory. Why? Because what I told you, error is RT minus CT. Okay, actually this output is oscillatory. When I say marginally stable system means output is oscillatory. Okay, the output is oscillatory. Input to fix. What is the input apply? Unit step function. Okay, the input is fixed at 1. Okay, but output is oscillatory. So error is oscillatory and hence steady state error is said to be indeterminate. Does not exist, or we call it as indeterminate. We cannot define the steady state error. Okay, acha, one more thing. Okay, if the system is unstable, if unstable system comes by chance, then steady state error is unbounded. Then steady state error unbounded. Okay, that will be infinity. Okay, that will be infinity, right? Correct. This much you should know. Now the characteristic equation of a LTI system is given, directly characteristic equation given when the system is marginally stable. Okay, find the value of K and the sustained oscillation frequency, because when the system is marginally stable, what I told you, marginally stable system means oscillatory, and whenever a system is oscillatory, it will have a frequency of oscillation. It will have a frequency of oscillation. Yes, Nuna Venkata, for GATE live batch, GATE 2029, the next online live batch will start from 17th August. That is the next Monday, 17th August. Okay, 17th August. Lucky, most of the questions that you saw and most of the questions how it comes in competitive exam, you will see some finite options coming. That means error is defined. Understood, na, Lucky? You see the previous questions. Okay, right? Yeah. If it can, if the type and input doesn't match, it can be infinity for that reason. Okay, right? But if the type and the type of input matching, for most of the case, you see maybe finite options. That means it is defined. Okay, because if it is marginally stable, there has to be option like indeterminate or oscillatory, something like that. Okay, or unbounded, there has to be option like unbounded. If such options you see, then it gives you a hint. Okay, check stability. That is the reason I did not mostly check in the previous questions. Okay, okay, Lucky. Next question here, guys. Okay, so yeah, when the system is marginally stable, so what I need to do for marginally stable, BC minus AD has to be 0. Okay, inner minus outer, that is K into 5 minus 1 into 10 is 0. Okay, 5K is 10, so K is equal to 2. Okay, K is equal to 2. And what is the frequency of sustained oscillation? Okay, so now for oscillation frequency, you have to do one thing, you have to form auxiliary equation. Okay, auxiliary equation, I'll come back to this question, let's discuss it in parts. Okay, K will be 2, that is correct. Okay, K will be 2 and answer will be A, because frequency of oscillation cannot be imaginary. Frequency is always real. So K equal to 2 itself alone is, enough to say answer as A here. Okay, but for frequency of oscillation, just wait. Okay, let's go to this question first and then I'll come back to there. I'll come back to that. Fourth order system. I am also taking a fourth order system here. Okay, let's answer with respect to this fourth order system. Yeah, the characteristic equation of a control system is given to you. Okay, s power 4 plus 2s cube plus 6s square plus 8s plus 8 equal to 0. Okay, which of the following is the symmetric root pair of the system? Which of the following is the symmetric root pair of the system? Now see, fourth order equation. For third order also there is a shortcut, and that shortcut is not random. That has come from Routh-Hurwitz only. Okay, whatever shortcut I have told you, this BC minus AD. Okay, for third order. Okay, especially for third order, this is a shortcut. Okay, but not a random shortcut. It has come up from Routh-Hurwitz criteria only. Okay, only thing is cubic questions are very common in your exam. Almost every competitive exam, cubic questions are common. Okay, that is why I have given you that shortcut. Now understand this question here with me first of all. Okay, and also understand the formation of Routh array in case if you have forgotten. Okay, so Routh array will be formed, okay, by taking the first two rows as s power 4 and s power 3. Okay, the s power 4 highest term and s power 3 next, and then s power 4 alternate coefficients you take 1, 6 and 8. 1, 6, 8, and then s cube 2 and 8 alternate terms. So 2 and 8 will come up here, and the next, if not there, I can write it as 0. Now how do you form s square row? How will you form the next row, s square? Okay, you will do reverse cross multiplication. Okay, take this structure, first column and the second column. Okay, because I am finding here whatever the column to the next of it. Inside this block, do the reverse cross multiply. Normally you solve a determinant this way, but you solve reverse. 2 into 6 minus 1 into 8. Okay, 2 into 6 minus 1 into 8. Minus 1 into 8. Divided by what? Divided by 2. Divided by first element of the above row. Now when you are writing this element, okay, take this block. First column will always remain same. The next column will keep changing according to this element. This element, what is the next column on the top? That you have to take up. Now see my calculation here. Okay, reverse cross multiply. 2 into 8 minus 1 into 0. Divided by 2. Divided by first element of above row. Divided by first element of above row. Last element will always be 0 because there is no next column. Now, s power 1 row. I will simplify this calculations then. What is s power 1 row? Okay, so when I simplify this calculation, this becomes 12. Okay, minus 8, 4. 4 by 2 will be 2. Okay, so I'll write down this number as 2 then. Okay, what will I write here? Acha, what it was? This is 0. 2 to cancel. This will be 8. Okay, now very clearly these two rows are identical, and if these two rows are identical, the next row 2 into 8 minus 2 into 8 0. This will anyways be 0 because the next column is 0, last element always 0. Now this is the situation I wanted to cover, important situation. Okay, the case of ROZ. Okay, ROZ, row of zeros. Okay, the case of ROZ. The case of ROZ, the case of row of zeros, right? The case of the ROZ, the case of the row of zeros. Okay, now whenever there is a row of 0, dear, please form an auxiliary equation. Okay, please form an auxiliary equation from the row above the row of 0. Okay, so whatever is the row above the row of 0, that will help you to form auxiliary equation. Okay, auxiliary equation will here be a quadratic equation because it is a s square row. So how will I write down the auxiliary equation? 2s square and plus 8. Alternate terms are there in every row. So 8 s power 0. So s power 0 no need to write, that is 1 only. This is known as the auxiliary equation. 2s square plus 8 equal to 0. Okay, 2s square plus 8 equal to 0. Okay, 2s square plus 8 equal to 0. Okay, now auxiliary equation will always lead to, okay, 3 different conditions. Okay, what is the roots you will get from here? First, let me complete the Routh array. My intent is to go to, okay, s power 1 row, which was 0. I have to form a modified s power 1 row. I'll call it as star s power 1. And for that, you will differentiate this auxiliary equation. Differentiate this, what do you get? D by ds. When you differentiate this auxiliary equation, okay, you will get 2 to 4s equal to 0. Okay, so what is the modified coefficient of s power 1? After differentiating, whatever is left, you write here. S power 1 coefficient now 4. Only one coefficient is there, rest 2 you can write 0. Now go to s power 0. Now when you are going to the s power 0 row, Okay, when you are going to the s power 0 row, consider these two rows. This is gone. This is eliminated. A new s power 1 row has been formed. Okay. So from here, 4 into 8 minus 0. So 4 into 8 divided by 4. So what will come up here is 8. Now see, these entire column 0, last element anyway 0. So this is the last row, 8 and 0, 0. 8 and 0, 0. Okay. Yes, Shivaram will try to do it for many subjects. Very soon, power electronics will come to you next subject, I think, very soon, within a day or two. Okay, stay connected to our channel. That's what. Okay, based on faculty bandwidth and availability, subjects will come. But yeah, mostly around Tuesday, you will get power electronics similar session. 50 important questions. Very important subject for you, no? Power electronics. Okay. And then mostly machines and power systems will also come, because core is always important in these exams. Okay, so if you are not subscribed, do subscribe so that you are notified about all the sessions coming up on the channel. Okay, so this is what is the route array. Now see, there is no sign change in the first column of route array. There is no RHP root. Okay, there is no RHP root, but auxiliary equation, see, it's not always necessary to solve it, but here it's an easy auxiliary equation. Na? Here it's an easy auxiliary equation. 2s square plus 8 equal to 0, meaning s square equal to minus 4, s equal to plus minus j2. S equal to plus minus j2. Okay, so this is your answer. What are the symmetric roots? Okay, plus minus j2. Okay, plus minus j2. Okay, remember that few important points I'll write down here. Okay, ROZ will come where? ROZ will come in odd power row. Like I got in s power 1, it will always come in s power 1, s power 3, like that. Auxiliary equation, that is why, will be a even polynomial. Okay, will be a even polynomial equation. Okay, will be an even polynomial equation. Okay, roots of auxiliary equation are also equal to roots of characteristic equation. They are also the final roots also. Whatever are the roots of auxiliary equation plus minus j2, that is also the roots of characteristic equation. That is why I have directly tick marked the answer as C. Acha. Auxiliary equation roots possibility. Okay, what are the type of roots will come? Okay, the roots are always symmetric. I'll write down a line here. They are always symmetric with respect to origin. How they are symmetric with respect to origin? Three possibilities, whenever auxiliary equation coming, one or more of these possibilities may come. I'll write down all the three possibilities for you. Okay, the first possibility what I have shown you, okay, the roots, okay, may be plus minus jy, pure imaginary, okay, plus jy minus jy. Second possibility, roots may be plus minus x. Okay, plus minus x. Okay, this is plus x, this is minus x. Okay, equal magnitude, opposite sign. Or there may be a quadrature of poles like this, plus minus x, plus minus jy. Okay, x plus jy, x minus jy, minus x plus jy, minus x minus jy. But in either case, the roots are equidistant. In all the three cases, roots are equidistant from origin. I have called it as symmetry with respect to origin. Acha, there is also, if auxiliary equation cannot be solved, this was easy one. If auxiliary equation cannot be solved, okay, also remember one more thing. For auxiliary equation, always, okay, the number of RHP, I'll start with LHP, number of LHP roots is equal to number of RHP roots and equal to, see here, na? In first case, there is no LHP, no RHP. L and R both 0. Here, both 1, 1. Left 1, right 1. Here, third case, left 2, right 2. So, number of left and number of right roots for auxiliary equation will always be equal. Okay, number of LHP roots is always equal to number of RHP roots for auxiliary equation. Okay, but what is number of RHP roots? Number of RHP roots is number of sign changes in the first column of Routh array, okay, but below auxiliary equation. Okay, number of sign changes below auxiliary equation, because I am finding the number of RHP roots for auxiliary equation. Okay, if I ask you total number of RHP roots of characteristic equation, okay, if I ask you total number of RHP roots for characteristic equation, it is equal to total number of sign changes. Total number of sign changes in the first column. Total number of sign changes in the first column. Okay. Total number of sign changes in the first column. Okay. Okay, Pradeep, we'll try to have a separate session onto it. If that virtual calculator thing is there. Total number of sign changes in the first column of Routh array. Okay. So see here, I had that Routh array. Na? This is what is the Routh array I formed. Yeah, this one. Right. So when you see the total first column, any sign change in the first column? No, everything is positive. Everything is positive. Correct? Everything is positive. Okay. Acha, number of sign changes below the auxiliary equation. This much is auxiliary equation part. Okay. Is there any sign change here? No. Okay. That is why for auxiliary equation there is no RHP and no LHP root. Proof is here. For auxiliary equation there are only imaginary roots. There is no left and there is no right hand root. Okay. And answer was plus minus J2. Okay. For this overall equation, if I ask you how many LHP, how many RHP roots for the overall, okay. For the overall characteristic equation, okay, that was s power 4. Question is what? S power 4 plus 2, 6, 8, 2s cube, 6s square plus 8s plus 8 equal to 0. Okay, how many roots on j omega axis? How many roots on RHP? RHP nil, no sign change. Okay, j omega axis roots 2. Okay, there is a pair on j omega. How many LHP remaining? It's a fourth order equation. Huh? It's a fourth order equation. Out of the 4, 0 is in RHP, 2 on j omega, 4 minus 2 is known as 2. 4 minus 2 is known as 2. This is the answer if I ask you the quantity of each and every root. If I ask you what? If I ask you the quantity of each and every root. Okay. Next. Acha. Now see, they may sometime ask you basic minimum or non-minimum phase. That also let's review the final pole zero condition. Now see, the open loop system represented by the transfer function. Okay. Now the options are also for open loop system only. Open loop system represented is what? They are not asking about closed loop system. Okay. So see here, what are the poles of the given open loop system? What are the poles here? Minus 2, minus 3 when I take the denominator 0. Okay, all poles are in LHP. Okay, so the system is stable. The system is stable. Okay, a system is stable. Okay, but for a system to be minimum phase, okay, the system is minimum phase if all poles, stability means only poles, but a system is minimum phase if all poles and zeros are in LHP. Okay, are in LHP. Now, I will write down the zeros. Okay, what is the zero? 0 is S equal to 1. Okay, RHP. Okay, the system cannot be minimum phase. System is minimum phase if all poles as well as zeros are in LHP. Okay, so answer for this question is system is stable but non-minimum phase. This is the correct answer. It is stable but non-minimum phase. Even this can be a fundamental question. Okay, answer has to be B. Correct. This one answer has to be B. Right. Yeah, most of you got it. B correct only. Okay, now next. Root locus will come later. Okay, root locus will come to it later. Okay, now let's come to this question. Okay, we'll first go to this question. Okay, consider the control systems with the following transfer function. Okay, first order system given. Yeah, so I was telling you, whenever it is first order system, one frequency domain question that they may be there. Okay, first order normally transfer function you will write k is divided by 1 plus st. Okay, what is the bandwidth? We define the 3 dB bandwidth. 3 dB bandwidth, okay, omega 3 dB, okay, as 1 upon T. For first order, I told you two time response formulas may be important for you, rise time and settling time. Okay, and for frequency domain, the 3 dB bandwidth would be important to you, that is 1 upon time constant. Okay, so for the first system, okay, 1 plus 3s, okay, time constant is 3, okay, and 1 plus s, the time constant here is 1. Okay, so we have to compare the bandwidth, okay, which is reciprocal of T. Okay, inversely proportional to T. So what will I say here, dear? T1 is greater than T2, okay, and higher T is denominator, that means lower bandwidth. Okay, so omega 3 dB for the first system will be less than the omega 3 dB for the second system. Okay, so the bandwidth of the system 2 is greater than that of the system number 1, option number B. Yeah, already some of you given the answer B. Yes, B is the correct answer. Okay, and here for the unity feedback control system with the forward part transfer function, this is going to be second order. Okay, the peak resonant magnitude, okay, the peak resonant magnitude MR, okay, for second order, this can be a important question, that is resonant peak or resonant frequency. Okay, the resonant peak MR is given by the formula 1 upon 2 zeta under root of 1 minus zeta square, under root of the 1 minus zeta square, correct? Okay, this is MR, okay, and omega R, okay, omega R, resonant frequency, okay, omega R will be given by omega N under root of 1 minus 2 zeta square. Okay, under root of 1 minus 2 zeta square. Okay, both these formulas are valid. Yes, one more important point, if zeta is less than equal to 1 by root 2, if zeta is less than equal to 1 by root 2, okay, if zeta is less than equal to 1 by root 2, yeah, but if zeta is greater than 1 by root 2 or greater than or equal to, I'll include only less than here, boundary condition will anyways match. If zeta is greater than equal to 1 by root 2, MR will be 1 and omega R will be 0. The peak is only obtained at 0 frequency and that is 1. Beyond that, it's a decreasing function. Okay. So, we need to find the resonant peak of the closed loop frequency response, but the formulas depend only zeta and omega n. So, let's work out zeta and omega n, and whenever we need to work out the zeta and omega n, I know that only what is going to be required is characteristic equation. So, I will write down the characteristic equation. 1 plus k upon s plus 2 equal to 0, s square plus 2s plus k equal to 0, but they have given reverse, they have given the resonant peak is 2, MR is 2, okay. Now, MR is 2, Achha, I'll give a simple way to solve this equation, 1 upon 2 zeta under root 1 minus zeta square, otherwise you will make it as a quadratic equation and solve. I'll tell you a time saving approach. Okay, remember that zeta is cos phi, na? I told you long back, zeta is cos phi. So, MR can also be written as 1 upon 2 cos phi under root 1 minus cos square theta is sin theta. Okay, and 2 cos theta sin theta is sin 2 theta. So, 1 upon sin 2 phi. You can use this way also. Okay, if you use it this way, calculations will be easy. Why it will be easy? See now, MR, I will use the formula 1 upon sin 2 phi, which is equal to 2. Okay, so what is the value of sin 2 phi? Is 1 by 2, and 1 by 2 is the value of 1 by 2 is the value of sin 30 degree, that is pi by 6, or it is equal to sin 180 minus pi by 6. Okay, that is 5 pi by 6. Okay, so at least I get some value of 2 phi from here. 2 phi is pi by 6, okay, or 5 pi by 6. This is 2 phi. Okay, so what is going to be phi, that also I can write down from here. Okay, if you want, you can write it in degree also, no problem. Okay, 30 degree or 150 degree. So what is that phi? 15 degree or 75 degree. But what is zeta? Zeta is cos phi. Okay, acha, what is cos phi then? Okay, I'll write down for both. 0.96. First one is 0.96. Second one is, okay, 0.26. Okay. This will be the wrong answer. This will be the correct answer. Why? Because I told you zeta has to be less than 1 by root 2, and 1 by root 2 means 0.707. That is why I will choose the value of zeta as how much? Okay, 0.26, not 0.96. Zeta is 0.26. Okay. Now again I will take back the characteristic. Okay, characteristic equation was s square plus 2s plus k equal to 0. This term we know is 2 zeta omega n, which is 2. 2 and 2 cancel. Zeta is 0.26 into omega n is 1. So omega n is 1 upon 0.26. Okay. So what is the value of k? K is in the place of omega n square. Okay. So 1 upon 0.26 whole square. Approximately how much will be the value of k? I will write down. Okay, 14.8. Approximately the k value is 14.8. Approximately 15 also can be written, no problem. Okay, I think options were not given here. Yeah, so whatever is the closest option to 14.8, if options were there, you can solve that. Okay, so this can be one possible question from the omega r or mr. I asked mr, even omega r can be calculated. Okay, now you know the omega n also, no? And you know zeta both, so you can calculate omega r also. Done? Yeah. So approximately k can be 15th. Okay. Now let's cover a crucial part here first. That's why I told you root locus will go later. The Nyquist plots, gain and phase margin, Bode plots. Let's cover this, crucial part first. Okay. Have a look into it. The Nyquist plot for the open loop transfer function of unity negative feedback system is shown in the figure. Okay. If GS has no pole in the right half of S plane, number of roots of, the question is asking the number of roots of the system characteristic equation in the right half of S plane. Okay. Now, what formula you will apply? See here, what formula you will apply for stability or for number of encirclements or for number of roots with respect to Nyquist plot. Okay. From the Nyquist plot, the number of encirclements of the critical point -1, 0 is observed as n equal to p minus z. I specifically write p plus minus z plus. Okay. This is okay for clockwise Nyquist contour. If not mentioned, you can take clockwise only. Okay. But if it is anti-clockwise Nyquist contour, then the formula just reverses. It becomes z minus p. You should know this. This knowledge should be there for you. Okay. Acha. Now let's come to the important terms. N equal to p plus minus z plus. What is n? N is the number of encirclements of -1, 0 by the Nyquist plot, by the GSHS plot. Okay. Now, N also has a sign convention. It is positive for anti-clockwise encirclements. Okay, and definitely then it will become negative for clockwise. It has the sign convention. It is positive for anti-clockwise and it is negative for clockwise encirclements. Okay. P plus is known as the number of poles of GSHS in the RHP. So plus is the symbol to make you recall that the number of poles. It's not a number of poles of GSHS, it is the number of poles of GSHS in RHP. Okay, that is in the positive side, LHP negative side. Okay, Z plus is the number of zeros, not of GSHS. Z plus is the number of zeros of 1 plus GSHS in RHP. That means number of zeros of this equation becomes 1 plus GSHS equal to 0. How do you get zeros of any function? By making it 0. Okay, and this exactly becomes characteristic equation. So Z plus is also nothing but roots of characteristic equation in RHP. Okay, now for stability, what do you want? If there is minimum one root in RHP, system will become unstable. Na? So what should be this Z plus for stability? This Z plus has to be taken as 0. This Z plus has to be taken as 0 for stability. The Z plus has to be taken as 0 for stability. Understood? Yeah, this is the point to be applied. Okay, so now, roots of characteristic equation also means poles of the closed loop system, poles of closed loop transfer function, correct? Poles of closed loop transfer function in RHP. Now see here, what is the question telling? Okay, the Nyquist plot of GS is given. The Nyquist plot we draw for GSHS only, and it is unity feedback, so GS given. If GS has no pole in the right half of S plane, important point, GS has no pole in the right half of S plane. What is that P plus? P plus is the number of poles of GS. HS is 1 here. P plus is the number of poles of GS in RHP, and there is a direct statement given to you. Okay, GS has no pole in the right half of the S plane. That means that P plus is given to you 0. Okay, the number of roots of system characteristic equation in RHP. Okay, roots of characteristic equation in RHP is known as Z plus. Okay, roots of system characteristic equation in RHP is known as what? Is known as Z plus. Question is Z plus. Okay, for Z plus what will I do? I will analyze the encirclements of -1, 0. Now please tally here with me. Okay, please tally with me. How many times -1, 0 encircled? See, this is one encirclement of -1, 0. Okay, this is clockwise. Okay, this I went in the direction of clock. Okay, this direction. Okay, now -1, 0 one more time encircle. How many times you are moving around -1, 0? That many times it is encircled. So see, there is one outer encirclement also which completely encircles. Completely means one full circle, one full rotation has to be there. Okay, but this encirclement, okay, is in anti-clockwise direction. Okay, so here what is the net value of n? Okay, I will write down a simple data here. -1, 0 encircled how? Encircled once in the clockwise sense by the inner loop, by the small loop you can say, and it is encircled once in the anti-clockwise sense. It is encircled once in the anti-clockwise sense, okay, by the outer loop that you are able to see here, by the outer loop. So what is the value of n? Okay, whenever it is in clockwise sense, you take minus, anti-clockwise sense plus, so no net encirclements. Okay, we call it as net encirclement, which is 0 here. Okay, which is 0 here. Now I will apply the formula. What formula I will apply? N equal to P plus minus Z plus. Okay, N is 0. P plus is given in the question as 0. What is the value of Z plus? Okay, so if everything is 0, Z plus also 0. So the answer to the question is 0. The answer to the question is 0. Option number A. This is what you should know. This is one common question that can be produced from Nyquist plot. Okay, this is one common question that can be produced from the Nyquist plot. Okay, that can be produced from the Nyquist plot. Now let's go to the next question. Okay, let us go to the next question. What is there in the next question? Acha, one more thing I will add on here. Sometimes, see, for stability, so we need the zeros of 1 plus GSHS, roots of characteristic equation. Okay, but whenever, just as the knowledge you should know, okay, whenever you talk about encirclements of 0, 0, okay, if they want to ask you what is the number of encirclements of actual origin 0, 0, okay, then you can still apply the same formula, n equal to P minus Z, assuming clockwise Nyquist path. Same clockwise Nyquist path, otherwise the formula will reverse. Okay, but if you are noticing the encirclements of 0, 0, P plus will be the same. Okay, Z plus definition will be zeros of GSHS. See here, the definition of Z plus will change. The Z plus will be the zeros of GSHS in the RHP. Z plus will be the number of zeros of GSHS in the RHP, correct? Number of zeros of GSHS in the RHP. Okay, number of zeros of GSHS in the RHP. Number of zeros of GSHS in the RHP. Okay, done. number of zeros of GSHS in the RHP. Now see a next question. For the below given Nyquist plot, calculate the number of open loop poles on the right hand side of the S plane for the closed loop system to be stable. Now see here, okay, for the closed loop system to be stable, okay, I told you know for stability what I want, Z plus 0. Now if Z plus is 0 means N equal to P plus minus Z plus, Z plus is 0, okay, this Z plus is 0, so P plus is equal to N. And the question is asking you the number of open loop poles, the poles of open loop transfer function on the right side, that is P plus. The question is asking P plus only. Okay, so P plus equal to number of encirclements. Okay, right, P plus equal to number of encirclements. Okay, P plus will be the number of encirclements of say minus 1 comma 0. Okay, minus 1 comma 0. Now come up here. Okay, of course, where is minus 1 comma 0? On the left side, na? Minus 1 comma 0 on the negative x axis it will be there. So how many times encircled? So see, there is one loop. If I highlight here, okay, there is this one loop. Okay, I can take it here also, which is not at all encircling minus 1 comma 0. This is of no use. Okay, but then there is this another loop here. Okay, which has encircled totally minus 1 comma 0, and this is anti-clockwise. This is anti-clockwise, correct? Right. So what is the value of N is 1 plus 1 because anti-clockwise is there. Okay, plus 1. Okay, whatever is N value, same will be P plus. P plus equal to N equal to 1. Equal to 1. Option number A, please tick mark. Option number A. Okay. Conceptual but easy question. Okay, if you just know that concept. Indra, normally for stability, we'll never check the encirclement of origin. If they separately ask you, okay, if they separately ask you how many times it will encircle the origin, 0, 0, then you have to use that second definition. But that time you have to consider zeros of GSHS only, not 1 plus GSHS. If they ask, so that additional thing I have told you. But if the question is on stability analysis, then you have to consider the encirclement of minus 1 comma 0 only, as we are doing here or in the previous question. Now look into this. Consider the standard negative feedback configuration with GS given to you, S square plus 0.2S plus 100 upon S square minus 0.2S plus 100 and HS equal to half. Find the number of clockwise encirclements of minus 1 comma 0 in the Nyquist plot. Now see, some people might think number of encirclements of minus 1 comma 0 in Nyquist plot. Some people may think the number of encirclements we can only obtain once we draw the Nyquist plot, and if you start drawing the Nyquist plot here, okay, you will spend a lot of time. You will be spending a lot of time if you start drawing the Nyquist plot here. Okay, rather what will I say? Okay, method number 2 is, okay, use this formula only, na? N equal to P plus minus Z plus. Okay, what is P plus, what is Z plus? If you can figure out, then you can calculate the N, na? Okay, you can calculate the N if you can figure out P plus and Z plus. Now, what is P plus? Okay, let's come to the GSHS, open loop transfer function here. Open loop transfer function, GS into HS, when I multiply, HS is constant half, so it will look like S square plus 0.2S plus 100 whole divided by 2, that 1 by 2 multiplied, na, upon S square minus 0.2S plus 100. Plus 100, right? So what is going to be the characteristic equation? What is going to be the, acha, let's find out the poles here, na, first. GSHS poles, that will be open loop poles. Okay, so for poles I will solve this denominator. Okay, now what are the roots I am going to get? Minus b. Okay, that is plus 0.2 plus minus root over b square. Okay, 0.2 square minus 4ac minus 400. Okay, divided by 2a. This is definitely negative. Small minus very big number, and under root of negative number will be imaginary answer. So what are the roots I am getting? 0.2 plus minus j something. Don't solve it fully. Plus minus j something divided by 2. Okay, when you divide by 2, actually this will become 0.1. Okay, 0.1. But this is positive real part. Okay, so where will you draw these two poles? Okay, both are RHP. Because the real part is positive, both will be somewhere here. like this, like this. Okay, this is 0.1, the real part. This is 0.1. Okay, na? Now, these are the poles of GSHS in RHP. How many? 2. How many? It is 2. So, I will say that the P plus value is 2. Is that clear now? I will say that the P plus value is 2. Okay. Now, I want Z plus also. I want Z plus also. For that, I will go for roots of characteristic equation. What is my characteristic equation? 1 plus GSHS. Okay, 1 plus this S square plus 0.2 S plus 100 divided by S square minus 0.2 S plus 100, and there was a factor of 2 in the denominator. Now, when I solve it, 2S square plus S square, total 3S square, minus 2 into 0.2 plus 0.2, it will be minus 0.2 S only, and plus 200 and plus 100 plus 300 equal to 0. Again, same story there, S equal to minus B, that is minus minus plus 0.2 plus minus root over same 0.2 square minus 4 AC, 4 3 12 into 3 3600, okay, divided by 2 into A. Okay, this will again look like, okay, some 0.1 by 3 plus minus J of something. This is positive again, that means both are in RHP. Okay, so what is Z plus? Z plus is also 2. Z plus is what? Roots of characteristic equation in RHP. So Z plus also 2. Now what is the answer? N, as I told you, will take P plus minus Z plus. Both are equal to 2. So N is 0. So number of encirclements is 0. Neither clockwise nor anti-clockwise. Okay. The number of encirclements is 0 here. Understood? Answer will be 0. Tell me any doubt here. Tell me if you have any type of doubt here. Okay. Done. Next question then. Before I come to drawing this polar plot, let's continue the same model question. Again, that formula N equal to P minus Z. Okay, N equal to P minus Z. Same thing we'll do here. Okay. Yes, correct, Lalita. Answer was N equal to 0. Okay. Now see this. The open loop transfer function of a unity negative feedback system is given. Okay, the Nyquist contour is in S plane. This is for clarity. I told you, if not given, you assume clockwise, but this is the Nyquist contour. What values of S are taken? Nyquist contour I have not explained you today, but okay. Okay. Every 100% I cannot cover in this session, but what is important, that definitely I will cover. But I can only say that this is the Nyquist contour given, which is clockwise. Okay. And clockwise contour means that is where the formula P minus Z I am telling, otherwise Z minus P. So N equal to P plus minus Z plus. Now the next type of question is range of K for stability. Earlier we were just applying the formula. Here also we will apply the formula, but here we have to find the range of K for stability. Why? Because N is the number of encirclement of minus 1 comma 0. But where is minus 1 comma 0? Where is minus 1 comma 0? Okay, that minus 1 comma 0, I don't know the value of K. Okay, suppose K is 16. So 16 by 16 is exactly 1. This point exactly will be minus 1. Okay, right. Or if K is suppose 100. 100 by 16 is 6. So minus 1 will be much before it. Minus 1 will be much before it. Right. So it depends on the value of K whether N will come or whether N will not come. Whether N will come or whether N will not come. Okay. So where is minus 1 comma 0? That is not known. So I will have to take 3 cases. Okay, number 1 case I will start from here, minus 1 comma 0 outside. Okay, number 1 case, minus 1 comma 0 is outside. And when it is outside, so N is 0. There is no N. Okay, if it is outside, so what is the problem? It is not encircled, N is 0. Second case here, I will mention this as second case, and suppose this is my minus 1 comma 0. This is my minus 1 comma 0. Clear? Okay, so minus 1 comma 0 in the second case, how many times it is encircled? Okay, you see in the case number 2, You see in the case number 2, it has been encircled, okay, once, okay, but in which direction? See, the direction of arrow is anti-clockwise. In case number 2, this has been encircled once in the anti-clockwise sense, right? So n is equal to 1 anti-clockwise, that means positive 1. Okay, acha. Case number 3, okay, case number 3, I'll call it as 3 here, and suppose minus 1 comma 0 lies here. Okay, minus 1 comma 0. So now if you see, it is again encircled, okay, but in which direction? In the clockwise direction. Okay, in the clockwise direction. N is equal to 1 clockwise, and 1 clockwise is actually minus 1. Okay, right, 1 clockwise is minus 1. Okay, I know, Lucky, just wait for it, I'll comment that. Just let me explain you. My intent is Nyquist plot here. Okay, first let me complete my intent. Okay, but I would say very best observation. I was about to come to it as a smart approach later, but I want you to explain this type of concept. I'll tell you why I am explaining this also. Now see here. Okay, GS is given to me, na? Okay, so GS. Okay, what are the poles? Okay, this will have a pole in RHP S equal to 1. This is quadratic with zeta positive. Both of these poles will be negative. Okay, so for GS, when you calculate the poles, you will have one pole in RHP. Clear, everybody? There is this pole in RHP S equal to 1. Okay, and then these two will be, maybe you'll get some quadratic number, some complex conjugate pair, but with negative real part. Okay, so P plus is 1 here. Okay, so now the question was range of K for, okay, stability. The system is stable for Z plus equal to 0. Correct, na? The system is stable for Z plus equal to 0. Acha, if Z plus is 0, what is left? Okay, N is equal to P plus. But what is P plus? Is 1. What is P plus is 1. So I want the case where N equal to 1, then the system will be stable. I want the case when N equal to 1, then the system is stable. So what I told you? My final case was for stability, N should be equal to 1. Okay, N should be equal to 1, and that means case number 2. Okay, now case number 2, you understand that minus 1 comma 0 lies here. Okay, that means this distance, acha, I'll write down that this distance is how much? K by 16. Minus K by 16 is the coordinate because it is negative x-axis. And how much is this distance? Minus K by 7. Okay, so where should be this 1? Okay, this distance will be 1, na? Okay, so 1 should be, okay, in case number 2, 1 should be less than K by 7 and okay, this 1 should be less than K by 7 and this 1 should be more than this K by 16. And this 1 should be more than K by 16. Okay, so first condition will tell you 7 less than K. That means K greater than 7. And, okay, K is less than 16. 16 greater than K. So final range of K, 7 less than the K, less than the 16. 7 less than the K, less than the 16. Okay, answer is option number D. Sorry, option number A here. 7 less than K, less than 16. Answer is option number A. Okay, everybody. Okay, answer is option number A. 7 to 16. 7 to 16. But, okay, but why I explained you this whole story? Because most commonly in such questions, okay, like I have told you earlier also, they don't give you GS. Okay, like if I go back to, forget this, see this question, okay, there is no GS given, it is only Nyquist plot analysis. This particular question, okay, there is no GS given, they indirectly told, they have given you P plus, okay, but without giving GS. So if GS is not given, then you have to go for that formula only, N equal to P plus minus Z plus. Okay, that is why you should know this approach. In this question also, in this current question also, maybe I could have not given you this one, I could have only given you P plus equal to 1. Then you will have to solve by the number of encirclement method only, na? Okay, but here, what is that smart approach? Okay, that I will add on. Here, GS also given, completely given. Okay, so what can be smart approach? You want the range of K for stability, na? What can be one more smart approach? Even the Nyquist is easy only because you don't have to draw Nyquist plot. Drawing Nyquist plot may take time. Okay, but given and noting the number of encirclement also is not difficult. Okay, that is also easy, but what can be a smart approach? Okay, RH criteria. You can go for RH criteria. Okay, because you can directly form the characteristic equation. 1 plus GS, HS. HS is unity. Okay, and the GS is K upon S minus 1, S square plus 4S plus 7. K upon S minus 1, S square plus 4S plus 7 equal to 0, and solve. This I leave to you. And that too, it is going to be cubic equation. So cubic equation means that BC minus AD, inner minus outer you can do. Inner minus outer you can do. Right, everybody? Inner minus outer you can do here. Okay. Chalo. Now, using Nyquist plot only, okay. This Nyquist plot, what is important is this, n equal to this encirclement formula, that is typically more important. This leave it, will come to it at the later end. Okay, the polar plot. Okay, the polar plot, or I'll just give you one or two basic hints. See, what is a small shortcut to solve such questions when you don't have to draw the polar plot fully? Okay, when you don't have to draw the polar plot fully. Okay, see here. Okay, see here. Just use the simple shortcut. Okay, okay, theta d, okay, okay, for omega tending to infinity, that is the infinity diving angle, is given by the formula minus 90 degree into P minus Z, okay. For omega tending to 0, starting angle you will always remember as the formula minus 90 degree into N, minus 90 degree into N. Now what is N? Number of poles at origin. Number of poles at origin. What is P? Number of poles, total number of poles, not only at origin, total number of poles, and Z is the total number of zeros. Okay, but yeah, okay, if there is a 0 in RHP, if there is a 0 in RHP, starting angle will change by 180 degree, minus 90 degree into N plus 180 degree, and if there is a pole in RHP, starting angle diving angle will be fixed only. Starting angle may change if the function is non-minimum phase, either there is a pole or 0 in RHP. Okay, for pole the formula will change by minus 180 degree. Okay, by minus 180 degree. Okay, so now if you see here, what is the value of N? How many poles at origin? 1. How many total poles? 2. How many total? 0? 1, 0. Okay, that to RHP 0. That to RHP 0. Okay, so now tell me here, what is going to be my starting angle? What I told for starting angle, you see here, na? Minus 90 degree into N plus 180 because there is a RHP 0. Minus 90 degree into N plus 180 degree. Okay, the starting angle should be 90 degree. Okay, starting angle should be 90 degree, and 90 degree means positive y-axis, along positive y-axis. What should be the diving angle? Minus 90 degree into P minus Z, total number of poles minus total number of 0, which is 2 minus 1, which is 1. This is minus 90 degree. Minus 90 degree is the angle for what? Negative y-axis. Okay, so starting, that is omega equal to 0, okay, should be along positive y-axis. Okay, and diving should be along negative y-axis. Okay, now negative, starting, okay, should be plus 90 or minus 270, same only, 90, okay, or minus 270, 360 degree angle is the same only. Okay, minus 90 is same as this, minus 90 same as plus 270. Okay, that is not a problem. Okay, so this leaves us towards answer either A or B. If I see this much, answer is A or B. Okay, because in both the case, polar plot is starting from positive y-axis. Okay, and then when it is diving, when it is terminating, okay, when it is coming to the origin, you see how it is coming. It is coming, that it looks like it is coming from which direction? It is coming from negative y-axis direction. It is coming from downwards, negative y-axis direction. Okay, so A and B are both correct as per this criteria. Okay, as per this criteria. So in such case, we will have to do one more basic analysis. Okay, in such case, I will have to do one more basic analysis. And what is that one more basic analysis to conclude A or B? Okay, to conclude A or B, yeah. If I write down Gj omega, most of the questions this will work. If it is not working, many questions will you can match the answer only by the starting and diving angle. Okay, starting and diving angle. Okay, one more thing. See here, C option. If you see C option, okay, when I am coming, when I am closing, I am closing along positive x-axis. I have to close along what? I have to close along negative y-axis. That is why C cannot be correct. When I write down this angle Gj omega, it will be k into -1 plus s equal to j omega divided by this j omega 1 plus j omega. And when I actually write down the angle Gj omega formula, when I write down the angle Gj omega formula, yeah, Karthik, it is 4 forward path. We corrected it. For question number 8, 4 forward paths, we have corrected that later. Okay. So this is equal to tan inverse omega upon -1. Okay. Minus 90 degree, pure imaginary number. And then minus tan inverse omega. This is the angle expression. Tan inverse y upon minus x is 180 degree minus tan inverse y by x. So this will be 180 degree minus tan inverse omega minus 90. Okay, minus tan inverse omega. Correct. Okay, so what is the final angle expression that is coming is, okay, 180 minus 90, 90 minus 2 tan inverse omega. 90 minus 2 tan inverse omega. So I was trying to tell you one small thing that, okay, when omega, okay, is a very small number, okay, for example, okay, if I take omega equal to 0.1, okay, what is the angle I will get? I have calculator now in my hand. Okay, so what is the omega, what is the angle that I am going to get? Let me put down this value. Okay, it is a positive angle. Okay, approximately I am getting some angle as 78 degree. Okay, and a point with the angle 78 degree will be in the first quadrant. Will be in the first quadrant. Okay, will be in the first quadrant. Okay, so that means after I start, I will be starting in the first quadrant. Omega equal to 0 starting, but when omega is just greater than 0.1, I should be seen in the first quadrant. Okay, I should be seen in the first quadrant. If this was slightly more than 90, okay, if this was slightly, see, even without calculating, you can do that. If this is omega very small, this will be some small number, but 90 minus something means you are below 90, first quadrant. If it was more than 90, then I will go to the second quadrant. Okay, so I will be in the first quadrant only. Okay, that takes us towards answer number B. Okay, that takes us towards answer number B. Okay, from this much, from the starting and diving, okay, I concluded that it is A or B. Okay, it is A or B, but final answer will be B. Okay, final answer will be B. Final answer will be B. Tell me any doubts here. Okay, if there is any doubts, you can mention here. Actually, so see, that's what I'm telling. For every question, you may not require to solve this angle. Okay, here we were stuck, so I solved it. Okay, but actually, okay, using this angle expression only for omega equal to 0 and for omega tending to infinity, I have given you the formula. This shortcut that I have given is using that only. Is using that angle expression simplified. So you don't have to simplify for many questions. I will say 90% of the questions can be solved using this. Some questions little bit here then may be stuck. So I solved by the angle expression. One more point. Okay. So this was done anyways. Yeah, almost a factual question. You should be able to say it to me. The Nyquist plot of a system is given in the figure below. Let omega p, omega q, omega r and omega s be the positive frequencies at the point p, q, r, s. Okay. Now, which of the point is gain and which of the point is phase crossover frequency? You have to tell me. See this enlarged picture and see me. Okay. See the enlarged picture and tell me which of the point is the gain crossover, which of the point is the phase crossover. Tell me. Let's do it. Everybody, tell me. This should be known to you. It's a direct factual question. See, what is the phase crossover frequency? And there I will calculate gain margin. Okay, phase crossover frequency is the frequency at which the Nyquist plot intersects the negative real axis. Okay, and if it's a numerical question, how do we calculate? If it's a numerical question, okay, we calculate this by calculating the angle expression like I did for the previous question. Calculate the angle, and the angle should be 180 plus or minus anything, because the angle on the negative real axis is 180 degree. Okay, but if it is a diagrammatic question, okay, it is the frequency at which Nyquist plot, or even if polar plot also given, fine, okay, intersects the negative real axis. Okay, right. What is gain crossover frequency? Acha, then we calculate gain margin. What is gain margin? Gain margin is the reciprocal of the magnitude at that point. Whatever is the magnitude, okay, mod Gj omega p, Hj omega p. Which magnitude? Magnitude at omega p. Magnitude at the phase crossover frequency. Okay, it is the margin by which the gain of a stable system can be increased. Okay, I am not deriving this formula. That much time we don't have. Okay, to go into detail, why the margin by which the gain of a stable system can be increased is 1 upon m. Okay, but yeah, you can use this formula 1 upon mod Gj omega p, Hj omega p, and in decibel scale, the common standard unit of gain margin is decibel scale, 20 log this value, 20 log 1 upon mod Gj omega p, Hj omega p. Okay, now gain crossover frequency, it is the frequency at which Nyquist plot intersects the unit circle. Okay, that means unit circle has the radius 1, magnitude 1. So at this point, okay, how will you calculate this gain crossover frequency? By taking the magnitude function and equal to 1. Whatever frequency gives the magnitude 1, that is the gain crossover frequency. This one is for numerical, that definition is for diagram. Okay, phase margin. Okay, it is the margin by which the phase of a stable system can be changed before it reaches instability. Okay, and again I am not deriving, I am just telling you that the phase margin to be calculated by this formula, 180 degree plus angle Gj omega g, Hj omega g. Okay, right? No, then it is not applicable. See, this shortcut definitely is only for, where is that shortcut I have written? Achha, that was previous question, na? Okay, this shortcut, okay, for number of poles greater than equal to number of zeros, or for number of zeros less than the number of poles. Better I'll write this way, the number of zeros less than the number of poles. Number of zeros less than the number of poles, then only diving will come up. Then only diving will come up. Otherwise, the polar plot does not dive to the origin. So, anyways, let's come back to the current question. Yeah. So, see here, where does the Nyquist plot intersects the negative real axis? Here, Q point. Q point. Okay. Right. This is the Q point. And unit circle is also shown to you. Unit circle means circle of radius 1. No? This is radius 1. Okay, so this side it is -1. On imaginary axis, 1 unit means plus j or minus j. So where does it intersect? So this particular is the unit circle. This dotted circle is the unit circle. Where the Nyquist plot is intersecting the unit circle? This is the S point. Okay, the Q points is the phase crossover, S point is the gain crossover. Okay, so omega, what I figured out, Q is the phase crossover, S is the gain crossover. Option number D. S is the gain crossover, correct, and Q is the phase crossover. Q and S. Correct. Answer is D for this one. Okay, it has to be D. Please recheck it. Correct. Yes, Vashist, correct. D it has to be. Okay. Now see, we will take some numericals, but one common function. Okay. In fact, this particular function is also the Nyquist plot. I will tell you. Okay, this is what is the Nyquist plot for a very common case. Okay. For the form of this transfer function, K upon S, 1 plus ST1, type 1 third order system, 1 plus ST1, 1 plus ST2, K upon S, 1 plus ST1, 1 plus ST2. Okay. Acha. Now, questions onto this transfer function, especially with gain margin, also very common. Acha, you should also remember some important key points. Okay, that can help you. Okay, gain margin and phase margin are both positive for a stable system. Gain margin in decibel in the standard unit and phase margin in degrees. For stable system, both positive. Okay. For unstable system, both will be negative, and for marginally stable system, both are 0. That means both will be of same sign. Both will be of same sign. Okay. If omega g less than omega p, that is the indication of stability. When both are equal, marginally stable. When omega g is more than omega p, the system is unstable. Okay. Acha. Now you come up here, the open loop transfer function of a unity negative feedback, the same transfer function I told you. Okay, what is the phase crossover frequency? Now this formula I will tell you, the phase crossover frequency. Okay, is the frequency at which, okay, I told you now what will you do? You will first write down gj omega, okay, and calculate the phase of it, k upon j omega 1 plus j omega t1 1 plus j omega t2. Okay. Now, what is the phase crossover frequency? The phase crossover frequency of this function. Okay. What will you do for phase crossover frequency? You have to put angle gj omega at j omega equal to plus or minus 180 degree. Okay. Now, what is going to be the angle expression? It can be anything plus or minus, but what is the angle expression here? Numerator is positive real number, so 0. For any denominator term, what is the phase you write? Negative. Okay, so pure imaginary, how much phase? 90. Okay, x plus j y, tan inverse y by x. Denominator term means write down minus phase. Minus tan inverse omega t1 minus tan inverse omega t2 is minus 180 degree. Okay, so because everything is minus, I am choosing minus only. So you will get tan inverse omega t1 plus tan inverse of omega t2 equal to 90 and 180 you cancel, so 90 will be left. Okay. Right. Now we will simplify the answer, tan inverse A plus tan inverse B. Tan inverse of A plus B omega t1 plus omega t2 upon 1 minus AB. So when these two multiply, you will get omega square t1 t2 is equal to 90. Now what is tan inverse 90? What is tan 90? Infinity. So that means this answer should be infinity, and this answer is infinity if denominator is 0. Okay, denominator is 0 means 1 minus omega square t1 t2 0. So omega will be 1 upon root t1 t2, and that omega is omega p. That omega will be omega p. Okay, correct. Okay, so 1 upon root t1 t2. 1 upon root t1 t2 will be the omega p. So remember, okay, for this form k upon s, commonly asked question, so you can remember this formula if you want, k upon s 1 plus st1 1 plus st2, omega p will be 1 upon root t1 t2, and at omega p what is going to be gain? At omega equal to omega p, the gain will be, okay, the gain will be, gain means mod gj omega at j omega. That is going to turn out to be k t1 t2 upon t1 plus t2. K t1 t2 upon t1 plus t2. Okay. So what is going to be gain margin then? If this is gain, what is going to be the gain margin? Gain margin is 20 log 1 upon this magnitude, reciprocal of this magnitude, that is t1 plus t2 upon k t1 t2. Done. Okay. Next question. Gain crossover frequency and phase margin for the transfer function. Now, I need omega g and phase margin. This is a question on phase margin. First of all, let's quickly convert to the frequency domain. I'll get 1 by j omega, 1 upon the j omega, 1 plus j omega here. 1 upon j omega, 1 plus j omega here, correct? Now, what is the magnitude and phase for this function? Mod gj omega. When I write down magnitude, 1 is 1, j omega magnitude omega, x plus jy magnitude root over x square plus y square. So root over 1 plus omega square. Then what is angle of gj omega? What is going to be the angle of gj omega? What is the angle of gj omega? Okay, now numerator is positive real number 0. Denominator again subtract the phase, j omega 90, and again x plus jy, so tan inverse y by x, tan inverse omega by 1. Now, I want gain crossover frequency. Okay, what is the gain crossover frequency? Okay, what happens at omega g? This magnitude function has to be equated to 1. That means 1 by omega under root 1 plus omega square. This has to be equated to what? This function, it has to be equated to 1. Okay, it has to be equated to 1. Correct, na? Right. So when I equate this to 1, what I'm going to get? Let's shift it on the right side. So omega under root 1 plus omega square will also be equal to 1. Okay. Then if I square it, omega square into 1 plus omega square, this has to be 1. Okay. Now see, if you want, you can verify the options. There are only two options, 1 or 2. Okay, 1 or 2. Definitely option does not look correct. If I substitute 1 also, 1 and then root 2, no, it won't match. And if I substitute 2 also, anyways, at any cost, it will not match. Options are wrong, it seems. Or, yeah, 1 is not matching. Na? Did I do any calculation error? No, it looks correct. Only 1 by omega under root 1 plus omega square. I have to equate it to 1. Okay, if I try to solve, see, this will normally become fourth order equation, but every term is omega square. Na? To solve it, put omega square equal to x. So this omega square, this will become x square. This will be plus x and minus 1 equal to 0. So what is going to be x if I solve from here? I'll write down the roots for you directly. Calculations you do accordingly later. So I am getting x is equal to 0.61, or rather I'll write it as 0.62 approximately, minus 1.62. Now what is x actually? X is omega square. Okay, square cannot be negative, otherwise you will get imaginary roots. Okay, so what is going to be omega square? That is x value is 0.62. So what is going to be omega g? Okay, under root of 0.62. Under root 0.62, 0.79 approximately. 0.8 I will write down approximately, 0.8 radian per second. That's why I'm telling options are wrong here, I think. Okay, 0.8 radian per second is the correct answer. Okay, 0.8 radian per second. Now what is going to be the phase there? I think they have taken omega 1, and that is why then 45 will also match. Now exactly that will also not come. So error, some typing error or what, I don't know. Okay, so at omega g, which is equal to 0.8, what is the angle gj omega? What was the angle expression? I'll substitute here. Na? Minus 90 minus tan inverse omega. Minus 90 minus this tan inverse of 0.8. Minus the tan inverse of 0.8. Okay. Okay, so this one is 128.6 approximately. Minus 128.6. But what I told you? What is the phase margin? Phase margin formula is 180 degree plus this angle. 180 plus angle of gj omega g. So, why it is automatically moving? What is the issue? Yeah. So 180 degree plus of this minus 128.6 degree will be approximately 51.4 degree. 51.4 degree. Okay. Right. Okay. So definitely, if you want the nearest option, you can take 1, but it is actually not correct. Okay, this is the nearest option. Okay, that can match. Okay, but what is the actual value? I will write down here. Actual value is 0.8. Phase margin approximately, if I write also, 51 degree. Okay, 0.8 and 51 degree. But okay, if actually these are the option, you can take it as A. Understood, na? You can take it as A. Another question related to phase margin. Another question related to phase margin. Okay. See here. Consider the stable closed loop system shown in the figure. The magnitude and phase values of the frequency response of GS as given in the table. Find the positive value of Ki, a integral controller. Okay. This is okay. Even if you don't know, no problem, you can solve it. Okay. But this is what is the integral controller. 1 upon S, integral term. Okay. This is a integral controller block added. Okay. What is the positive value of the gain Ki for a 50-degree phase margin? Okay, for the 50-degree phase margin. Okay, so I need a 50-degree phase margin. That means, okay, phase margin formula 180-degree plus angle, okay, angle of the whole open loop transfer function. Now these are going to be cascaded. Okay, so I'll come up here rather. Okay, so what is going to be the overall, okay, forward path gain? Okay, I will call it as G1S, and G1S will be Ki by S into Gs. Okay, because these are cascaded blocks. Okay, now understand this question here. Okay, so what is going to be G1 J omega? That will become Ki, okay, into Gj omega, okay, divided by S, that is divided by J omega. Okay, okay. Now, I want angle of G1 J omega because this is the final open loop transfer function. Okay, so angle of G1 J omega, Ki is a positive real number. It's clearly mentioned Ki greater than 0. And sorry, not mentioned, but Ki has to be by default positive only if not mentioned also, any gain. Okay, so it will be angle of Gj omega, which is given in table. Denominator subtract minus 90 degree. Okay, so what I am looking for, now understand, I am looking for a phase margin of 50 degree, and phase margin means 180 degree plus this angle of G1 J omega, final phase margin. Okay, this should be 50 degree. Okay, now I'll substitute angle G1 J omega, that is angle of Gj omega minus 90 degree. Okay, and this right side is 50 degree. So from here, okay, what is angle of Gj omega? I want 180 minus 90, 90. When you send on the other side, 50 minus 90, 40. So angle Gj omega minus 40, yes, that entry is here for me. That phase entry is here. Okay, that phase entry is here. Okay, so where is the phase margin calculated? Okay, phase margin is calculated at omega g. At omega g. So if this is the point, okay, of phase margin, this has to be omega g. This becomes omega g. Okay, now the magnitude in decibel is minus 7. Okay, so from here omega g is how much? 0.5. 0.5. This is from the table I have taken. Okay, omega g 0.5. But now what happens at omega g? Omega g gain crossover frequency, the magnitude, overall magnitude of this function, mod of G1 J omega, this should be equal to 1, or in decibel. In decibel, if the table is given data in decibel, 20 log mod of G1 J omega should be 0, because log 1 is how much? Dear, log 1 is how much? Log 1 is 0. Okay. Now, what is going to be the magnitude of this term in decibel? Okay, log A into B, log of AB by C. Okay, so first term will be 20 log Ki, log A plus log B minus log C. Okay, next term will be 20 log mod Gj omega. Next term will be denominator minus 20 log mod of omega. Mod J omega means mod omega. So that will be 20 log omega. Okay, omega means omega g here, and this net result should be 0. Now, in the table, this one is given to you as minus 7 dB. Again, you can refer to the table because, okay, at omega g, okay, at omega g, the gain, magnitude in decibel, okay, of Gs, this is the table of Gs. Okay, so that is given as minus 7. Okay, so here 20 log Ki minus 7 minus 20 log omega g is 0.5 is 0. So what is going to be 20 log Ki is 7 plus 20 log 0.5. Okay, 0.5 is 1 by 2. So minus 20 log 2 and 20 log 2 is 6. So this much will be approximately 1. Okay, so from here we have to calculate Ki. Okay. First of all, log ki will be 1 by 20. So ki, because it is log to the base 10, 10 raised to the power 1 by 20. Some small value only it has to be. Okay, 1.12. 1.12 is what I am getting. You can check the calculations, right? Okay. Okay. This is the answer. For 35, what you are telling? I have not taken any options. No problem. We have to find the gain ki. I have taken this question, Vashishta, without option. That is okay. You are telling for this question 35 only, na? Right. CP Puppy, see, these are not the CSE related videos. Okay, our channel will only serve ECEE and instrumentation students. Home Institute is only for electronics, electrical and instrumentation branch. Okay. Yeah. Let's go to the next one. Okay. The two transfer functions are given. Okay, so some compensator based question, then I'll start with the Bode plots also. Okay, the transfer functions of two compensators are given below. C1 equal to 6s plus 1 upon s plus 6. Ct equal to s plus 6 upon 6s plus 6. Okay, which of the following statements is correct? Okay, which of them is lead or lag compensator? Which of them is lead or lag compensator? Simple question, but very expected in your exam. Okay, very expected in your exam. Okay, see, for C1, okay, what is the pole or 0? Okay, for C1, the pole from denominator s is minus 6 and the 0 is s equal to minus 1. Okay, who will be closer to origin? Minus 1, na? Okay, 0 dominant. 0 dominant is always a lead compensator. 0 dominant is a lead compensator. Why? Because 0 is minus 1, pole is minus 6. Dominant means who is closer to the origin in LHP, but who is closer to the origin. Okay, so C1 is lead. Okay, what about the other one? Okay, for the next one, again, if I write down pole, reverse, minus 1 and 0 is at minus 6. So, minus 1 is closer to origin. Huh? That means it is pole dominant. Pole is going to be closer to origin. Oh, sorry. In the previous question, I have drawn this symbol as wrong. Pole 0 symbol I wanted to draw. Okay. So, 0 dominant. This was 0. This is the pole. Okay. Now, here, okay, when I draw the picture, minus 1 actually corresponds to the pole and 0 is at minus 6. Pole dominant, and pole dominant represents lag compensator. So, C1 is lead, C2 is lag. Okay, let me see, anybody answered? Yes, A answer correct. Lucky correct. Vashist correct. A answer. Achha, you have applied for AEE electrical. Okay. Maybe I didn't read that comment. Okay. Puppy, connect to me in Telegram once, because the exam is very near. If you have specifically applied for AP exam, okay, and if you don't even know syllabus, it will be little tough to target this exam if you are not even clear about syllabus and any preparation right now. Exam is going to come in the next 12-13 days, right? Okay, done guys. Question number 37. The effect of phase lead compensator. Now these questions are also something. Okay, so what I have done for you, I told you sometimes some theory also I have included today. Okay, for your ease, okay, the general effects of lead compensator, the general effects of lag compensator I have included. Okay, see, lead compensator, okay, the lead compensator actually increases the omega G, the gain crossover frequency, which will increase the bandwidth, and bandwidth and rise time are inversely proportional. If you remember one conclusion also, okay, so it will increase bandwidth, okay, and decrease rise time. Achha, this is never possible, both increase or both decrease. Why? Because bandwidth and rise time are inversely proportional to each other. Always for any system, be it first order or second order or any order, bandwidth and rise time are inversely proportional to each other. Like you remember first order formula, rise time 2.2 t proportional to time constant, bandwidth 1 upon t reciprocal of time constant. Okay, so naturally bandwidth and rise time will become inversely proportional. Okay. So yeah, any sort of question may come up from here. So you can revise this when you are revising this particular PDF. Okay. Next question. Now on a lead compensator, what can be the next type of question? Okay, a lead compensator is given to you. Now normally whenever this numerical question coming, you can write down the lead compensator generally this way: 1 plus st upon 1 plus s alpha t. General lead compensator, 1 plus st upon 1 plus s alpha t, alpha being less than 1. Okay, this can provide a maximum phase shift of how much? Okay, this can provide maximum phase shift. A and B options were same or what? No. Right. Acha, sorry, I didn't note. Sorry, we can change it, na. I think they both have been typed same, but okay. Then the first one should be rise time increases and bandwidth decreases. Okay. So B option I have taken, right? B option I have taken. Yeah. So for phase lead compensator, okay, it can provide a maximum phase shift of phi m given by the formula of sine inverse 1 minus alpha upon 1 plus alpha at omega m of 1 upon t root alpha. At what frequency maximum phase shift? If they ask, then omega m you have to calculate. Okay. Or this is equal to geometric mean of both the corner frequency. Corner frequency from 1 plus st is 1 by t. Corner frequency from 1 plus s alpha t term 1 plus alpha t. Geometric mean means root over AB. Okay. So you can do that way also. Okay. Anyways, right now the question is only maximum phase shift. Okay. So when I compare the given form, okay, to the standard form, time constant 0.12 and alpha into t is 0.04. Okay, so alpha into 0.12 is 0.04. So this will give you alpha 4 by 12, alpha will be 1 by 3. Phi m depends only on alpha, and that phi m will become sine inverse of 1 minus 1 by 3 upon 1 plus 1 by 3. Easy expected question, but this will become sine inverse of 2 by 3 upon 4 by 3. Okay, they will cancel as 1 by 2. So this is sine inverse of half, and half is obtained at 30 degree. Options are in degree? Yes. 30 degree is the answer. Answer is option number D, that is 30 degree. Answer is the option number D, and that is going to be 30 degree. Okay, correct answer 30 degree. Okay, now 30 degree, lucky, final answer 30 degree, option number D. Exact value will get sine inverse half, because sine 30 degree is half. Okay, done. If it was lag compensator also, the set of formulas will be same actually. Okay, I will revise this also quickly. If it is lag compensator, you will remember it in the form of 1 plus st upon 1 plus s beta t for beta greater than 1. Okay, but phi m and omega m formula same. Sine inverse of 1 minus beta upon 1 plus beta, maximum phase lag at omega m, which is equal to 1 upon t root beta. Same formula. The formulas will remain same. Okay. Yes, Vashishta, correct. 38 answer is D. Okay. Next question here. A unity feedback closed loop system has a plant 1 upon s square, GS 1 upon s square, and a PD controller, okay, GCS, okay, in the feed forward path. Okay, GCS is given as TP into 1 plus STD, where TP and TD are positive adjustable parameter. Which of the following statement is not true? The system is stable or what? A basic analysis on a PD controller. Okay, with every data is given to you. This question is like a unity feedback system. See, number one, the system is unity feedback. There is no doubt in that. Okay, this is unity negative feedback. This is the input. Okay, say this is the plant. Okay, whose gain is given to you as 1 by s square. Okay, the controller, the PD controller is a forward path controller. It is connected in cascade. Okay, this is the PD controller. Okay, whose gain is how much? Whose gain is TP into 1 plus STD. TP into 1 plus STD. This is connected in cascade with the plant gain. This is what is my PD controller. Okay, what the question is asking, the system is stable or system may have damped oscillation or what? Okay, which of the statements is not true? Not true actually. Okay, always remember PD controller. Okay, PD controller is again some effects. I think I have not brought the effects of controller. If I'll try to add the effects of all controllers and in the PDF, and then I can share in the Telegram. Okay, PD controller is also going to increase bandwidth, and bandwidth increases means noise effect will always be more. Okay, it will amplify the noise. This is a true option. Okay, this is going to amplify the noise. Acha. Regarding stability, or it may have damped oscillation, or it has zero steady state error for unit parabolic input. Acha, see here, what is the overall forward path gain now? What is the overall forward path gain? Okay, now these two are going to be multiplied, na? Okay, so when you multiply them, you will get TP into 1 plus STD divided by S square. Is it not type 2? Is it not type 2? Okay, so what type of error is expected for parabolic? Will it be 0? No, this option is wrong. Straight away you can mark from here. Okay, type 2 steady state error for parabolic input. Steady state error for parabolic input is finite. Okay, that is given by 1 upon Ka. So that means, okay, this answer is the false option because the error will be 1 upon Ka, which will be finite here, because the question is type 2 question. Okay, D answer is not correct. But is it always stable? That you can prove. Okay, that also if you want you can prove here, because you can only write down the characteristic equation. Characteristic equation will become 1 plus GSHS equal to 0. HS unity, this is GS. So it will become S square plus TPTDS plus TP equal to 0, where TP and TD are positive. TP and TD are positive adjustable parameters. Positive adjustable parameters. Okay, so TP positive, if both are positive, the product positive. Second order, no Rautherwitz required. Okay, in second order, when all coefficients are of same sign, the system is stable. Okay, right. And also 2 zeta into omega n. Omega n will be root TP is equal to TP TD. So you can have some zeta from here. That will be one root cancel. Root TP into TD can be divided by 2, and zeta can take any value. Zeta can take any value. The question I was asking, the system may have damped oscillation for unit step input. Okay, yes, this is also true if zeta is between 0 to 1. Okay, this is also true. Okay, the system is always stable. This is also true. Okay, the third option was also true. Only fourth is not true. Okay, yes, the second option also true. If zeta between 0 to 1, the zeta can be adjustable by the, these are what, positive adjustable parameters. You can adjust the values, okay, to get zeta less than 1. Is that okay? You can adjust this value to get what? To get the zeta less than 1. Okay, done. Next question then. Yeah. Right. In the context of Bode magnitude plot, come on, quickly tell me. 40 decibel per decade is same as what? In context of Bode magnitude plot, 40 decibel per decade. Always remember, another unit of slope is decibel per octave, and 20 decibel per decade is same as 6 decibel per octave. Okay, you can always remember this. Okay, so 40 is double, so 6 into 2, 12. It has to be 12 dB per octave. They can, be asking very basic question also, conversion of slope, decibel per decade to decibel per octave. Okay, decibel per decade to decibel per octave. Next question. Now, the asymptotic magnitude plot of a minimum phase system is shown in the figure. The transfer function is arranged in this form: k s plus z power a upon s power b s plus p power c. Right? Correct? Yeah. Where K, Z, P, A, B, C are positive constants, find the value of A plus B plus C. That means I need A, B, C individually. See here, reverse, and from Bode plot, it is always reverse question in any type of competitive exam. Okay, reverse, inverse Bode plot. I mean, given Bode plot, you have to extract the transfer function. Okay, rather than a transfer function given and to draw Bode plot. Simply, okay, remember a simple point there. Suppose, okay, suppose the GSHS is given in the form K 1 plus ST1 1 plus ST2 upon S power n 1 plus STA 1 plus STB. Okay, where n is the number of poles at origin. Remember, okay, that when I talk about the Bode plot for 1 plus ST and 1 upon 1 plus ST, these two individually are more important. Okay, when you talk about the Bode plot of 1 plus ST or 1 plus ST, both have a corner frequency. Okay, both have a corner frequency known as 1 by T. Okay, both have the corner frequency which is reciprocal of time constant. This is a zero term. Okay, 1 plus ST, simple zero. Simple zero means first order zero. Okay, simple zero, that is first order zero, and this is a simple pole. Okay, simple zero and a simple pole. Simple zero and a simple pole, first order pole. Okay, both have the corner frequency 1 by T. Okay, and up to the corner frequency, the magnitude is 0 dB. There is no effect in magnitude, and after the corner frequency, the magnitude here increases, there decreases. So, how do we remember? We simply say that, we simply remember like this, that whenever corner frequency comes, slope will change. But how much slope will change? For zero term, plus 20 decibel per decade. For a pole term, minus 20 decibel per decade. Number 1 point. Okay. Acha, see, one more thing I'll write down. Okay, when it is 1 plus ST, okay, or 1 upon 1 plus ST, corner frequency for both is 1 by T. Okay, sometimes question may be given in the S plus A format, S plus A or 1 upon S plus A, then the corner frequency is equal to A. Okay, either ways you can remember. Okay. Now, one more thing, okay, that will be important normally in handling the question is initial part. What do I mean by initial part? Okay, initial part of the Bode plot is the part before the first corner frequency. Okay, before the first corner frequency. That automatically means before all corner frequencies. That automatically means before all corner frequency, before the first slope change point. Okay, the initial part will be given by this very important formula, minus 20 n log omega plus 20 log k. Initial part will be given by the formula minus 20 n log omega plus 20 log k, and it intersects the 0 dB axis at omega equal to k power 1 by n. Okay, where n is the number of poles at origin. But yeah, by chance if there are zeros at origin, suppose m, then the formula rather than minus 20 n will become plus 20 m. Okay, acha, this also, okay, if this is the initial part, there are questions only on initial slope of Bode plot. So, what is the initial slope? Minus 20 n decibel per decade. Okay, or for this formula, okay, if this is the formula, if there are zeros at origin, the formula plus 20 m log omega plus 20 log k. Okay, they change it to plus 20 log m. Okay, in this case, initial slope will be given by plus 20 log m. This is initial slope. There may be a question, before I come back to the previous question, see, there may be a question on final slope. Okay, final slope, or commonly known as high frequency slope, which is the slope as omega tends to infinity, which is the slope as omega tends to infinity. Okay, and that final slope in Bode plot, you can always remember minus 20 into P minus Z decibel per decade. P total number of poles, Z total number of zeros, same notation. This also is a very separate expected question. Okay, now let me come back to the previous question. Yeah, if I see this previous question, the initial slope is minus 20. Okay, this initial slope has to be compared with minus 20 n. If it is negative, compare with minus 20 n. Okay, so from here you will get n is equal to 1. What is n? 1 pole at origin. So we have 1 pole at origin. That is anyways given in the function also, s power b. Now 1 pole at origin means b equal to 1. 1 pole at origin means b equal to 1. You have to follow b equal to 1. Okay, B is the number of poles at origin. So when I say one pole at origin, B equal to 1. Normally I write S power n in denominator. They have given S power B. So B equal to 1. ABC we have to find the B obtained. Okay, B obtained. Now look into this. Okay, this line is parallel to x axis. Okay, so how much is the slope for a line parallel to x axis? Zero slope. Okay, but what is important is the change in slope. You have to measure what? Change in slope. Okay, so from minus 20 the slope becomes 0. That means you have to add 20. Minus 20 plus 20, 0. Then only the slope will become 0. So how much is the change in slope? Positive or negative? Positive 20 means this is the location of a 0. This is the location of a 0. Okay, there is 1 0 at some frequency omega 1. Let's see if I have to find that omega 1. Okay, now see here, please, next point. Okay, next point. Okay, slope is 0, now it becomes minus 40. What does it mean? Okay, slope decreased from 0. How will you go to minus 40 from 0? Okay, by subtracting 40. By subtracting 40, and when you subtract 40, okay, that corresponds to 2 pole because of 1 pole, because minus 40 can be written as minus 20 into 2. So this point, okay, where slope changes by double of 20, decreases by double of 20, should be 2 poles. Okay, 2 poles at omega 2. 2 poles at omega 2. Now, what are the poles? That is okay, not required, but still from this much of the information, no more slope change. Okay, so I can say that the function should be in some format of k. Okay, now 2 poles at omega 1, and here there are 2 poles, s plus p power c. Okay, s plus p power c. So whatever is gs given, now if I rewrite this gs here, actually every answer can be noted. Gs is some k s plus z power a upon n s raised to the power b s plus p raised to the power c. Okay, now see, okay, this is b equal to 1, poles at origin. Now there is a 0. Okay, where is that 0? Omega 1. That means this z is omega 1, not required. They are not asking z, but how many 0? 1 0. A equal to 1. Okay, there are poles at what frequency? Omega 2. So this should be s plus omega 2 term. Okay, but how many poles are there? 2 poles. So this should be power 2. This should be power 2. Okay, so A is 1, B is 1, C equal to 2, and A plus B plus C. I asked the final consolidated question. Answer is 4. Right? Yes, some of you are giving answer 4, which is correct. Okay, the value of A plus B plus C is exactly equal to the 4. Is exactly equal to 4. That is what is the correct answer. Okay. That is what is the correct answer. Done. Next question. This is what was for quick revision. Initial part of Bode plot I revised, final slope I told you. Yeah, the open loop transfer function of a system is given to you. GSHS equal to 100 s plus 10, 100 upon s plus 10. In the straight line approximation of the Bode plot, mod Gj omega Hj omega, okay, in decibel they are asking, at omega equal to 100. What will be the magnitude at omega equal to 100? At omega equal to 100. Yeah, this is a question where I'll have to think a bit about, sketching of the Bode plot. I'll have to think a bit about sketching of, not very detailed, but a bit of sketching. Okay, but for sketching, always convert the GSHS in the standard form so that I can use the correct initial part formula. GSHS is 100 s plus 100 upon s plus 10. Okay, I want to convert to the standard form. Standard form means time constant. Okay, I want to convert to the standard form. Standard form always means the time constant form for first order term. Okay, so it will be obtained if I take 100 common. Okay, 1 plus s by 100 divided by denominator, I will have to take 10 common, and then this term will become 1 plus s by 10. Now you see both the numerator and denominator terms I have converted to 1 plus st. Okay, 1 plus st. Okay, 1 plus st. Vashishta, this is almost like a marathon only. Only thing is we are taking through questions. We are taking through questions. Okay, it's almost like marathon. If you have followed till now, you have seen almost majority of the topics we have revised. Okay, I am revising important bullet points, important theory as well, not only question answer. So it's almost, it's not technically, but it's almost like a marathon that you can, see here. Okay, so what is the final GSHS in the standard form is 110, I'll cancel 100 by 10, 1000 will be left. Okay, into 1 plus S by 100 is divided by S 1 plus S by 10, and this is whatever is the K in the standard form, that is the K to be used in the initial part formula. Okay, now I will start drawing the initial part. Okay, what are the corner frequencies here? Corner frequency, zero corner frequency. Where is the zero? Corner frequency is reciprocal of time constant. What is the corner frequency formula? Reciprocal of time constant. So for zero, the corner frequency is 1 upon 1 by 100, that is 100. Okay, for pole, what is the corner frequency? 1 upon 1 by 10, that will be 10. Reciprocal of time constant, first pole will come. Okay, first pole will come, right? Okay, first pole will come, then zero will come. But what about the initial part? Okay, I am going to use this initial part formula. That is why I have taken the value of K. What are there? There is one pole at origin. So initial part formula, when there are poles at origin, we write minus 20n log omega plus 20 log K. Because I am going to use this formula, that is why I wanted K, and K is the K of standard form. K is the K of standard form. Okay, so n is 1, K is 1000. 1000 means 10 power 3. Okay, so magnitude will be minus 20 log omega plus 20 log of 10 power 3. 3 outside, log 10 will be 1 because it is base 10. So initial magnitude is now minus 20 log omega plus 20 into 3, 60 decibel. Okay, my first corner frequency is omega equal to 10, that is due to pole. Now see, approximately I just want to draw this Bode plot, a freehand curve. Let us just try to plot this here. Okay, what is going to happen? The first corner frequency is at 10, the next is at 100, that is due to 0, this one is due to pole. Let me choose the starting frequency as 1. Any starting frequency you can choose before 10, below the first corner frequency. Initial part, as I told you, it is the part up to the first corner frequency. Up to first corner frequency, this is applicable. That means up to omega equal to 10. Okay, so if I exactly put omega equal to 10, what is the magnitude I will get? Okay, or if I choose omega equal to 1 also, omega equal to 1, log 1 is 0, magnitude will be 60. Omega equal to 10, okay, log 10 is 1, minus 20 plus 60, this will be 40. So important point is here I will draw a straight line. Initial slope is negative, na? Okay, the important point here is to be noted is, okay, at this frequency the magnitude is 40. At omega equal to 1, it is 60. This is initial line, minus 20 decibel per decade slope. Now because omega equal to 10 is what? This is a pole point, na? First is the corner frequency of pole. Okay, so because of pole, slope will decrease. This is the original direction of line. Because slope is going to decrease, okay, you will bend it downwards, and this will go up to omega equal to 100. So this slope is minus 40 decibel per decade. Okay. This will go up to omega equal to 100. Okay. Okay, what is going to be the magnitude here? That is what is the question, na? What is this magnitude? At omega equal to 100, what is the magnitude? Achha, if I want to further complete the Bode plot, what will I do? Now this is a 0. 0 will again increase the slope. Okay. 0 will again increase the slope. So line again bends upward. This was minus 40. This will now become minus 40 plus 20, minus 20 decibel per decade, because this corresponds to a pole and this frequency corresponds to a 0. Okay, so at pole what I have done? This is the slope change point. Okay, so at the pole I decrease the slope by 20. When a 0 came, I increased the slope by 20. That is what I have done. But I want the magnitude at 100. So for this, equation of line will be used. Lalita has given some answer 1.4. Okay, equation of slope will be used. Okay, what is the slope formula generally? Slope formula is y2 minus y1 upon x2 minus x1. But in Bode plot, y-axis means magnitude axis, magnitude in decibel, divided by slope is, in Bode plot, what is the x-axis? It is not frequency, it is log of frequency. Bode plots, log plots. Okay. So I will use the line segment. Suppose this is some point A, this is some point B. Okay, I will use the line AB. I'll use the line AB. The slope is minus 40. The change in magnitude is, here it is M, here it is known to me 40. Not required. Conceptually, I'll finish this question. Leave. This is the slope formula that you can use. I will finish this question conceptually, and that will ask me to change the Bode plot also. I'll do that. I'll do that. See, I'll rather solve this question. Okay, more in a conceptual format. See, I'll solve it conceptually. Better. No calculation required. I'll tell you why. Okay. Now see here, please understand, omega equal to 10 is one corner frequency and the next corner frequency is 100. Okay, next corner frequency is 100. Okay, next corner frequency is 100. Okay, so from 10, suppose this is 100, from 10 to 100, okay, how much is the change in frequency? 10 times, and this is what is known as one decade. This is what is exactly known as one decade. Okay, so how much is the change in frequency? 1 decade. Now understand the concept part. The concept is, what is the slope of this line? It decreased by 20 and the slope of this line was minus 40 decibel per decade. Okay, this means that magnitude, what is the meaning of this slope? This means that magnitude, okay, changes by minus 40 decibel for 1 decade frequency change. Okay, so for 1 decade, when the frequency multiplied by 10, magnitude should drop by 40. Minus 40 means drop by 40. So 40 minus 40 is 0. Okay, so I will modify this line also, and this line actually will go only up to 0 dB here. So dear, if this is 10, this is 100, this is known as 1 decade, this is into 10, this is 1 decade, and for 1 decade the magnitude should drop to minus 40, and what is going to be the magnitude here is 0 dB. What is going to be the magnitude here as 0 dB? The rest is the same. After that it will increase. Okay, because this was a 0 point, the slope will again, okay, increase by 20, minus 40 plus 20, this slope will be minus 20 decibel per decade. Whenever frequency, the next frequency is exactly given in the form of into 10, you can use this concept. Otherwise, you can use this formula to calculate any magnitude given the slope. This also I have left for you. This also you can use it. Okay. So answer is 0. Answer is 0 dB, option number A. Sridhar Sunil, anyways, Bode line always comprises of straight lines only. Okay. So answer is not 40. What logic you have used? If you elaborate, okay, that is not the correct logic. Okay. The answer is definitely going to be 40. Yeah. So I'll give you one homework from Bode plot. Okay, which is on the steady state error for ramp input. Now see here, I'll give you a few hints. Okay, the hint is this is minus 20. The initial slope should be minus 20n. So n equal to 1. One pole at origin means it is type 1. Okay, means it is type 1. And that is why the question is on ramp. Okay, the steady state error for ramp input will be 1 upon kV. And always remember, okay, if you choose the standard form, okay, it will be k. kV equal to k of standard form always, and just use what is the value of k, you will get the value of kV. Okay, and how will you get the value of k? How will you get the value of k? Okay, the k you have to calculate from initial part. Okay, from initial part. Complete this as homework. Easily you can do it. Initial part formula I told you, na? Use that formula, and that formula valid up to first frequency. Okay, remember that this is log omega given directly. Log omega 1. Okay, use this point that log omega 1 magnitude is 20, or log omega 0 magnitude 40. Anyone you can use, you will get your answer. Okay, this much I leave to you as homework. Okay, it will be easily done only, or rather I'll do it. What is there? Just another 1 minute only. Na? This hint itself was sufficient to complete it. Okay, so initial part is given by the formula minus 20 n log omega plus 20 log k. Okay, n is anyways 1. Okay, so I'll use this point. Okay, I am going to use, better to use this point. Na? I'll use this point, suppose point A. So if I use the point A, magnitude is how much? 40 is minus 20, n is 1, log omega how much? Here log omega 0. Directly the readings of log omega given, not omega. Okay, the log omega 0 plus 20 log k. Okay, so 20 log k is 40, log k is 2, and k will be equal to 10 raised to the power 2, k is 100. So steady state error will be 1 upon 100, 0.01. Finished. Option number D, 0.01. Steady state error from Bode plot. Okay, 0.01. Okay. Now very common question from state space analysis is the state transition matrix. Okay, firstly, what are the 2-3 most common cases that usually come to you? Okay, state transition matrix, which is defined as e power at, okay, which can be solved as Taylor series, but we don't usually follow it. We will follow the Laplace transform. This will be our preferred method. Okay, it will be given by inverse Laplace transform of Si minus a whole inverse. Okay, this Si minus a whole inverse is known as the phi s, capital phi s, that is the Laplace transform of phi t. Okay, inverse Laplace of this is known as the state transition matrix. What else may be asked? Okay, what is the ZSR? The solution of state vector. Okay, the solution of state vector. Okay, right. Now, lucky, in syllabus they have not mentioned, the syllabus they have copied from 2019. 2019 also syllabus you analyze, it was not there, but they asked some question. Okay, it is expected, that is what. That is why I am covering it. In syllabus it is not mentioned, but they have asked in 2019 also, where they did not mention in 2019 also. They have asked in 2017 also. Okay, some fundamental questions only, but they have asked. So what is the solution of state vector? Okay, the total solution of state vector is actually noted this way. Okay, see, so when you talk about state model, when you talk about any state space model always comprises of two equations. Number one, state equations. Okay, what are the state equations? X dot t is equal to a into xt plus b into ut. Okay, this is the state vector xt that I am referring to, and then output equation. Those who have totally left the topic, considering it is not in syllabus. Yeah, that's what was 2017 and 19 syllabus same as what is this year, na? Control system same exactly, right? So that is why in both the years question was there. So if you have left it, you can go through it. Okay, if you totally don't know this topic, you can watch my earlier videos, state space analysis details videos. If you can watch, this is like a quick review only. Output equation is given by y is equal to axt, sorry, y is equal to cx plus du. Okay, u here is the input term, xt is the state vector, yt is the output term. Okay, this xt is what is the state vector. The solution of state vector is given as, okay, we solve it in two parts rather than solving it fully. It is solved as xzirt plus xzsr2. Okay, what is the zir part and what is the zsr part? Okay, that is noted here. Okay, that is noted here. Okay, ZIR part phi t into x naught. Phi t means state transition matrix. Okay, and ZSR means you have to solve this calculation. Inverse Laplace of, okay, inverse Laplace of, okay, phi s into b into us. Okay, right now the question is only state transition matrix, and how will we solve the state transition matrix? This state transition matrix phi t, as I told you, e power at has to be calculated as inverse Laplace of si minus a whole inverse. Okay, inverse Laplace of si minus a whole inverse. And what is going to be this inverse Laplace? For that, first I will have to form si minus a. Okay, first we will form this matrix si minus a. A will be a given matrix to you. So S into I, identity matrix, all diagonal elements 1, others are 0, minus A matrix. And what is the A matrix given to me? 0, 2, minus 2 and 0. 0 and 2 and minus 2 and 0. When I subtract them, this is S into 1 minus 0, this is S, this is 0 minus 2, this is again 0 minus minus plus 2, and this is S and minus 0, this is S. Okay, now Si minus a whole inverse. How do you take inverse of any matrix? You will take adjoint of the matrix divided by the determinant of the matrix. Okay, for 2 cross 2, I will tell you a simple technique that everybody should know. Suppose the matrix was A, some matrix P was there, and that is A, B, C, D. Determinant to you all know. How will you calculate the determinant? Cross multiply AD minus BC. Okay, but how will you calculate adjoint of this matrix P? For 2 cross 2, it is simple, very, very simple. Just exchange the diagonal numbers. Just exchange the diagonal numbers. So D and A. For off diagonal numbers, don't exchange, just change the sign. Let this be minus B, let this be minus C. Minus B and minus C. Write it this way. Okay, so what is going to happen here is, okay, adjoint, exchange the diagonal numbers, so S and S. For off diagonal numbers, just change the sign. Okay, minus 2 will become plus 2 and 2 will become minus 2. Divided by determinant of this, so determinant we can write down S square minus of minus 4, that is S square plus of 4. S square plus of 4. See the Sunil, it is there in syllabus. I mean, it is not written. It was not written. That is why I am telling you every time. I will not say. I have already told this 2 times. State space analysis was not written in 2019, 2017 syllabus also, but they have asked the question. It is a fundamental part of control system. Maybe by chance they forget to write in syllabus. Okay, but you can't risk it. There were questions earlier year. You can check the 2019 paper, 2017 paper. There were questions from state space analysis. There were questions from state transition matrix, controllability, and all those questions were there. Okay. So this is Si minus a whole inverse. Last step, I will divide the S square plus 4 inside with every term, and this Si minus a whole inverse is known as phi s. Si minus a whole inverse, and this is going to become S upon S square plus 4. Okay, 2 upon S square plus 4 minus 2 upon S square plus 4 and S upon S square plus 4. S upon S square plus 4. Right. Now we have to take the inverse Laplace of this. Okay. Now we'll have to take the inverse Laplace of this. Let's do it here. Okay. So inverse Laplace for each and every term you will apply, and that inverse Laplace will be the state transition matrix, and that will be equal to how much? S upon S square plus 4, cos formula, cos omega t, S upon S square plus 2 square. So this is cos 2t. This one is 2 upon S square plus 2 square, sin 2t. Okay, this one is the negative of the earlier one, minus 2 sin 2t, and this is again S upon S square plus 2 square, that is cos 2t. Okay, cos and sin minus cos and sin, and this is also minus sin, not minus 2 sin. This is also minus sin 2t. So the final answer that I will match is option A. Final answer that I will match is option number A. Achha, not in this question, but sometimes, sometimes 1 or 2 observation will help you simplify the question. Okay, what is phi 0? Especially this case. t equal to 0, e power 0 is 1. In matrix world, 1 means identity. Remember, sometimes options you can match by this also, that whatever option when I put t equal to 0, it should be identity matrix. It should be identity matrix. So I get phi 0, which is equal to 1, which is equal to 1. Right, this I revised. I'll take a question on transfer function also, transfer matrix. Okay, the transfer function or transfer matrix will be given by the formula C phi b plus d. Phi s means the same, Si minus a whole inverse. This phi s means Si minus a whole inverse. Okay, now come up here. Okay, yeah, now see this. By the same logic we can solve this question. State transition matrix I explained you how to solve, but whenever a, this is a special case that I can note down, whenever A is a diagonal matrix, whenever A is a diagonal matrix, e power at will also be a diagonal matrix. Just take the exponent of the given diagonal numbers, e power lambda 1t, then 0, and e power of lambda 2t. Okay, so answer here will be e power 2t, e power 2t. Both diagonal numbers will be e power 2t, e power 2t. A answer. For this you can directly tick mark. Same procedure. What I explained you in the previous question, same procedure you can apply, but whenever diagonal matrix, no need to apply anything. You can write down your answer directly. You can write down your answer directly. Now, yeah, solve this question. The state space analysis representation is given, x dot is ax, y equal to 1, 2. Okay, for x not equal to 0, 1, what is the response yt? See, this question is on what? First of all, you understand x dot equal to some matrix ax. X dot is ax, okay, plus nothing. Normally, when you compare, you write down x dot equal to ax plus bu. So, why the second part is not given? Okay, input is 0, and that is where when I take input equal to 0, that is where comes the 0 input response case. Okay, that is where the 0 input response case will come. Okay, that is where the 0 input response case will come. Okay, so what is the response yt? Now see, y equation is cx, and that is given to me. Okay, 1 and 2 and x. Acha, y is equal to 1 and 2. What is x? X is a state vector. What is the meaning of state vector? The state vector is a column vector containing all the state variables. It is the column vector containing the state variables. There are two state variables, x1 and x2, because it is a second order system. Okay, if matrix A is 2 cross 2, it is a second order system. The number of state variables are always equal to the order of the control system. Okay, so this will be x1, x2. Okay, but which x? Okay, you have to find, because the question is on. Okay, before I come to this, I'll write down, because the question, the response of yt for 0 input, the question is yzir. For that, you will have to solve xzir. And the formula for xzir, I told you, xzirt is phi t into x naught. Is phi t into x naught. That is the formula you have to apply here. Phi t multiplied by x naught. Phi t multiplied by x naught. Okay. Complete this question quickly. Yeah, let's continue our discussion. What answers you have got, we can match it now. So see, phi t into x naught. So main thing is, what is phi t? Once again, you see, Once again you see what is the A matrix in the question. 2 0 0 3. Okay, so because it is a diagonal matrix again, state transition matrix e power at is known to us. We just have to take e power 2t here and e power 3t here. That's it. Okay, and then we have to multiply by x naught. So what is xzirt is phi t multiplied by x naught, and phi t is e power 2t 0 0 e raised to the power 3t multiplied by x naught. And what is the x naught? Is the initial value 0 1. Okay, that is given to me as 0 1. 0 and 1 here. So when you multiply, see first row e power 2t into 0, 0 into 1. First row is 0. Then second 0 into 1 e power 3t into 1. Second is e power 3t. Okay. Then as I told you, what is yzirt? Is c into x, that is xzirt. Okay, so what is going to be xzirt? Okay, that is calculated. C matrix is given as 1 and 2, that is given in the question. Multiplied by this 0 and e power 3t. Okay, 1 into 0 plus 2 into e power 3t. Answer is 2 e power 3t. Answer is 2 e power 3t. Okay, that is option number C. Option number C, 2 e power 3t. Option number C is the correct answer. Okay, option number C is what is the correct answer. Next question. Consider the state space model. X dot is ax plus br, like we write x dot is ax plus bu. Okay, input name could be anything. Okay, and y equal to cx. Okay, xt, rt, yt are the state input and output respectively. The matrices ABC are separately given. What is the sum of the magnitudes of the poles? Okay, now see, for calculating poles, I'll tell you one simple thing here. Sum of the magnitudes of the pole. See, poles. Okay, for poles, there are two methods here. Now, method number 1. Okay, first find the characteristic equation or find the transfer function. Do something. Okay, do something. Find the characteristic equation or find the transfer function. Do something. Okay, method number 2. Okay, use a simple direct property. Okay, that poles of the system. This is something that should be known to you. Important point. Poles of system are equal to eigenvalues of the matrix A. Poles of the system are equal to eigenvalues of the matrix A. Okay, eigenvalues of the matrix A. Okay, so if I can calculate eigenvalues of matrix A. Okay, so bit of mathematics if I apply here. Eigenvalues are what? Eigenvalues are roots of characteristic equation of matrix A. Okay, how do you write down characteristic equation? Determinant A minus lambda I equal to 0. This is known as the characteristic equation of matrix. But 95% of your questions, or rather more than 99% I would say for your level, okay, questions are on 2 cross 2 matrices. So for 2 cross 2 matrices, okay, okay, the characteristic equation is simply noted this way: lambda square minus trace into lambda plus determinant equal to 0. That's it, finished. Answer. I am not asking sum of the poles. I am asking sum of the magnitude of the pole. That is why I did not apply that point. Understood? That is why I did not apply the point. Sum of the magnitude of the poles. Okay. Right. Now, what is the A matrix given to me? 0 and 1. Okay. Minus 2 and minus 3. 0 and 1, minus 2 and minus 3. Okay. 0, 1, minus 2 and minus 3. Okay. Now, if this is the matrix A, okay, if this is the matrix A, listen to me. Okay, what is going to be the characteristic equation? Okay, lambda square minus trace. Trace is what? Sum of diagonal numbers. Minus 3 into lambda plus determinant. Okay, 0 minus minus 2. That will become 0 plus 2. Okay, so what is the equation actually? Lambda square plus 3 lambda plus 2 equal to 0. This is factorizable as lambda plus 1, lambda plus 2 equal to 0. So, lambda is minus 1 and minus 2. Okay. Okay. So, whatever is the lambda, that is the poles also. So, the poles of the system are minus 1 and minus 2. If you only sum up, answer will be minus 3. Okay, but I want sum of the magnitudes. Okay. Sum of the magnitudes is 1 plus 2 and that is 3. Okay. This was sum of magnitude, so answer will be 3. Please mind, answer for this question will be 3. But yes, if it was only sum of poles, okay, sum of poles means sum of lambdas. If the question is sum of poles, sum of lambdas, and then you can use the matrix property. Sum of eigenvalues is always trace of A, is always the trace of A. And if sometimes the question is on product of poles means product of eigenvalues and means determinant of A, means determinant of A, means determinant of A. Okay. Now, okay, although this question do not require transfer function or characteristic equation, I have solved it usually. This is the preferable method here. Okay, this is the preferred method here. Okay. But if the known function is any of the standard form, okay, let me write down. Okay, let me write down this matrix here. A is 0, 1, minus 2 and minus 3. Okay, I'll write down x dot equal to ax 0, 1, minus 2 and minus 3 into x plus bu. B is given as 0, 1, b into u, and y is cx. C is given as 1, 0. Right? C is given as 1, 0, I guess. Yeah, this is the data given to me. Okay, and then if you have to find transfer function, okay, if you have to find now the transfer function, this is the state space model. Okay, now method number 1, okay, again transfer function, one formula I told you, na, C into phi s into b plus d, but there is no d here. Okay, or method number 2 is some standard form. Now, at least 2 standard form. In the class, I have taught every standard form, but at least right now I'll tell, okay, 2 standard forms must be directly remembered for you always for helping out question. Okay, this particular model is a model known as CCF model. Okay, controllable canonical form. CCF, controllable canonical form. Okay, I'll give you the notes regarding it. Okay, just I've taken the classroom notes for ease of the calculations here to save time. State space model, whenever it is B into C1s plus C0 upon S square plus A1s plus A0, second order system. Okay, what is the CCF model corresponding to this? See, x dot is 0, 1, minus A0 minus A1. Okay, write down the denominator constant and then next term A1, both opposite sign. 0b, b if there is any common term in the numerator. Okay, now numerator you see what is the constant term C0 and then reverse, write down here C0 C1, same sign, that is C matrix. This is known as CCF form, controllable canonical form. Okay, observable canonical form, this is OCF, observable canonical form. Such a model is always observable. Okay, this is observable canonical form, this is known as controllable canonical form, CCF. Okay, always remember A matrix when you transpose, you will go to OCF model. Okay, B matrix transpose you write in place of C. C matrix transpose you write in place of B. This is the relations I have noted, I have just shown you. If it is third order transfer function, then also you see, please here, denominator constant, I told you to start the last row, denominator constant A0, then A1 and then A2 opposite sign, minus A0, minus A1, minus A2. Start with the constant. Okay, then here first column will be 0. This last row done, na? Above that first column 0 and this is identity matrix. Okay, this is identity matrix, 2 cross 2 identity matrix. Okay, plus 0, 0, b, b again same, any common in the numerator. Y equal to cx, what is the C matrix you see here? Take the constant term of the numerator, then go reverse, C1 and then C2, C0, C1, C2, same sign. Okay, and then the same transpose method will give you the OCF combination. So if I just pretty much apply this, If you want a transfer function, although I solved the previous question without transfer function, but if I want a transfer function, what will be my transfer function? So I will correlate this term. Okay, I'll tell you this is minus a naught minus a1. This term will be b and this will correspond to c naught and c1. So my transfer function has to be written as b c1s plus c naught divided by s square plus a1s plus a naught. So if I compare and write down the answer, okay, b is 1, okay, c1 is 0, so only c naught will come, that is 1. So numerator only 1 upon s square. What is a1? This is minus a naught and minus a1. Okay, so what is a1 is 3. Okay, so plus 3s plus a naught. What is a naught is 2. 1 upon s square plus 3s plus 2. Now you can find the poles now. If you solve, now you can find out the value of the poles. Minus 1 and minus 2. Minus 1 and minus 2 when you solve the denominator. Same thing I told here also. What are the poles? Minus 1 and minus 2. Poles of the system will always be equal to the, okay, eigenvalues of the matrices. So better to use that. Where magnitude plot is not intercepted, are you talking about intercepting the 0 dB axis? Shavali, are you asking about the intersection of the 0 dB axis? Please specify that doubt. Okay. Now here one question I will give you as homework. Okay. Right. Because for here you will have to first find the transfer function as well. You will have to find the transfer function as well. Okay. Because the system is given in state space form. Okay. Input is sine omega t. Okay, find the value of omega for which the steady state output will be 0. For any sinusoidal input, okay, for any sinusoidal input, okay, find the transfer function. Suppose the transfer function is, okay, I'll give you the hint. Find the transfer function, suppose Ts, okay, convert to Tj omega and write down that Tj omega in magnitude and phase form. Calculate the magnitude and calculate the phase of that transfer function. Okay. Right. Steady state output, when the input is a sine omega t or magnitude of input is 1, output will become modulus of Tj omega into that sine of omega t plus angle Tj omega. Sinusoidal response. Okay. Sinusoidal response. Okay. Right. So this I'll leave to you as homework. Any doubts, please specify to me in the telegram. I can help you solve this fully. Okay. This is what I revised to you. And this one. Now transfer function question. Now this is a pure transfer function question. The transfer function representation of the system, and this is not any standard form. Okay. This is not like CCF. CCF starts with what? 0, 1. OCF starts like this, 0, 1. Transpose, no? Okay, so you have to find by the formula C into phi s into B plus D. There is no D given. Okay, y equal to Cx. There is no D given. D is 0. So you have to find C phi B. This is B matrix. This is C matrix. No problem. Okay, you have to find the phi s matrix first of all. Now see, Shavali, if it is not intercepted, we extend it. Assuming that if it intercepts, then you can use that formula omega equal to k power 1 by n. Otherwise, that's why I directly use that magnitude formula. That does not create any confusion. Magnitude formula minus 20 n log omega plus 20 log k. But if it does not intersect, okay, we just extend it. Okay, if it was intersecting, where it will intersect? Find that point. Find that point. Okay. That way also you can do. Okay. So now we'll have to form. Okay, for this question, we'll have to find phi s matrix. Main effort is phi s matrix. What is that phi s matrix? Si minus a whole inverse. The type of calculation we were doing in the state transition matrix. In the state transition matrix. So let us do this Si minus a whole inverse. Okay. Si minus a first then only I can take the inverse now. So what is Si minus a matrix? A matrix is in front of me. So this is going to be S into identity minus A matrix, and the A matrix is minus 4 and minus 1.5, minus 4, minus 1.5 and a 4 and a 0. when I multiply them, my matrix will turn out to be, I'll write here, okay, s minus minus s plus 4, then plus of 1.5, 0 minus 4, and s minus 0, that is s. Okay, now I will take the si minus a whole inverse, which is equal to adjoint divided by determinant. While taking adjoint, diagonal numbers exchange now, s plus 4, and off diagonal number sign change, minus 1.5 plus 4. This is adjoint divided by determinant. To cross multiply, s plus 4 minus minus plus 4 into 1.5 will be 6. Okay, I don't want the inverse Laplace here. Okay, I don't want the inverse Laplace here. Okay, so this is si minus a whole inverse. Okay, so what is going to be the transfer function? As I told you, c into phi into b. The transfer function for the question has to be solved as c into phi s into b. D matrix is 0. Now I'll put down c and b. C is 1.5 and 0.625. 1.5 and 0.625 multiplied by phi matrix. What is that phi matrix? S minus 1.5 plus 4 and s plus 4 multiplied by b matrix. What is b matrix? Is 2 0. Is 2 0. And not only this one, this is whole divided by s square plus 4s plus 6. Acha, now whether to multiply these two or whether to multiply these two, it can be anything, your choice, but I will prefer multiplying these two, so that you know, if one element 0, it will make others also 0. It will make the calculation simple from beginning. So this 1.5 into 0 will go, only 2s will come. Okay, so what is the first thing I will write? 1.5, 0.625, C matrix as it is. Okay, and then this constant term, this divided by s square plus 4s plus 6, I will separate out. Okay, now this, see, 2s and then 0, not required. So only 2s left, easy. Then here 4 into 2, 8 plus 0. Okay, so only 8. Now calculations are easy. Okay, 1.5 into 2s, how much? 3s. Okay, 8 into 0.625, you calculate, you will get 5. Okay, done, calculations done, divided by this term, transfer function obtained. 3s plus 5 upon s square plus 4s plus 6. 3s plus 5 upon s square plus 4s plus 6. Option number A. This is also one type of question. This is also one type of question. Shavali, I replied to you, no? Please listen to that. Already I have replied to you. Okay, regarding your doubt. Okay, 3s plus 5 upon s square plus 4s plus 6 is your answer. Okay. Alright, last one, question number 50 for today. Given this state model, okay, is the system stable or is the system controllable? Is the system stable? Is the system controllable? Now please see, bit of mathematics I'll apply and then I'll come to the controllability. See, this is B matrix, this is A matrix. Okay, what type of matrix is A matrix? Okay, can I say it is the upper triangular matrix? I hope you know the basics of matrices. Okay, all the elements are in upper triangle. Below diagonal line, it is 0. It is the upper triangular matrix. Now see, whenever you have upper triangular or lower triangular or any diagonal matrix, eigenvalues are equal to diagonal numbers. No calculation required. Eigenvalues are equal to diagonal elements. Okay, so eigenvalues for this question are -1 and 2. So I told you na, eigenvalues of A, why they are important? Eigenvalues are equal to the poles. So what are the poles? -1 and 2 is a RHP pole. So system cannot be stable. That answer is finished. It is unstable. Okay, it is unstable. Okay, it is unstable. Okay, so now comes the state space model. Okay, given, okay, x dot equal to ax plus bu, and suppose output equation given y equal to cx. Okay, suppose this much, d is suppose 0 only. Okay, what is the Kalman's controllability test? What is that Kalman's controllability test? Okay, form the matrix S, which is given by B, AB, keep adding all these matrices A square B up to A raised to the power n minus 1 into B. Okay. Now, 99.99999% probability if a question is coming will be second order for you. How much I told? 99.99999% probability question will be second order question. Okay, almost 100% I told. Okay. So when n is equal to 2, the matrix will be only constrained to B and AB. You normally we form up to A power n minus 1 into B. Okay, but if n is 2, it will become A power 1 into B. So only these two terms. B will be given in the question. You have to form AB. Write down both together. That together matrix is S matrix, controllability matrix. Okay, now if determinant of S, okay, check the determinant of S. If that is non-zero, then you can say the system is controllable. Okay, if it is 0, then the system is not controllable. It should have non-zero determinant. Okay, similarly, if I want to specify, although the previous question is only asking controllability, but you should know this also. If I specify Kalman's observability test, okay, I will ask you to form this matrix. Form observability matrix CA downwards, CA square up to CA power n minus 1. But what I told you, okay, you expect second order question. So we will again only contain two terms, C and CA. C will be given, okay, CA is one thing you have to form. Okay, and now I will ask you to check what? To check determinant of B. If it is non-zero, system is set to be observable. If it is by chance 0, the system is not observable. It is not observable. Correct? It is not observable. That is how it is going to be. Tell me. Chalo. Now, for the given question, see A matrix and B matrix, because it is only controllability A and B given, C not required, C is required for observability. So I'll just copy A and B. A is minus 1, 2, A equal to minus 1 and 2 and 0 and 2, and B matrix is given as 0, 1, I guess. I'll check once again. Yeah, 0, 1, minus 1, 2 and 0, 2, correct. So first of all, I'll form the AB matrix. When I multiply them, minus 1 and 2, 0 and 2, multiplied by B matrix, 0, 1. Okay, so when you do first row, first column, minus 1 into 0 gone, plus 2 into 1, this is 2. 0 into 0 gone, plus 2 into 1, this is 2. Okay, so this is your AB matrix. Okay, but then I told you to form what matrix? S matrix. And what is that S matrix? B and AB placed together, one after the other. B is 0, 1. AB is 2, 2. Okay. Next, I told you check determinant of S. What is the determinant? Cross multiply 0 minus 2. The determinant is minus 2. Is it non-zero? Yes. If it is non-zero, I'll say the system is controllable. Okay. So this point also revised. The system is going to be controllable. Okay. The system is what? Not stable, but controllable. Option number C is what you have to tick mark. Okay. Option number C you have to tick mark. Just a second. Yeah, Telegram link definitely I'll now share. I'll share the Telegram link where the PDF will be provided. PDF I'll provide, let's see, by tonight or maximum by tomorrow. Okay. So Telegram link I have shared, and now this was the 50th question. Okay. Now I'll tell you only one thing here. Unfortunately, only two questions I missed out today. That's okay. Now it's more than 4 hours of non-stop session without any break. Okay. Without any break. We did not even go for any break. Okay. So the time to stop here. Okay. Only thing not done is root locus. Okay. That you can, revise on your own. Only, not that important also. Question number 23 and 24, I think. These were the only two that I have left. That is with respect to root locus. So one topic I request you can revise on your own, or you can watch our previous YouTube videos if you want. Okay, but very fundamentals they ask from root locus. Okay, so but unfortunately, let's stop here. It's more than almost the time is approaching 4.5 hours. That too without a break. Okay, that too without a break. But yeah, we have done enough justice to the subject in terms of number of questions, level of questions, and the theory that I added with every question, so that it becomes a proper revision session rather than only a question practice session. Okay, that is why it took a bit of good time. Okay, so only root locus not done. You can do this question number 23, 24. I guess 23, 24. Okay, I'll check it here in my system only. Because going back to this PDF will be a bit lengthy. I have that original PDF now. Yeah, 23, 24. That's it. Okay. So that's what is honestly not done, that I am telling. Rest all important areas we have done, but root locus totally we could not touch. Okay, now PDF password. Control system 50. CS50. C and S small. C and S in small. Control system 50. Okay. I'll share the PDF in the Telegram group. Link of Telegram I have shared. Okay, that you will get maybe by tonight or tomorrow. Okay. And the password will be, okay, password will be CS50. C and S small, control system 55, CS50, 50 questions. Okay, randomly I've set the password. Please don't keep asking for any passwords, or don't keep sharing any passwords in the group, because this password is a reward for your dedication. You have even, along with me, you have been following the session for more than 4 hours non-stop live without any break. Okay, so you basically, what I believe is, this notes is for the dedication. Okay, is for the students who are following the sessions dedicatedly. Otherwise, if you don't follow, what is the use of simple notes also? Not useful. Okay, so those who have watched, or even if some of the students may watch later, then also they can get the password. Okay, those who have followed, they get the password. Simple rule. Okay, so quick update all of you. Quick update to all of you is that the Independence month is here, and the Om Institute announces 15%, flat 15% off on all the GATE, AEE online courses, all the online courses, live as well as recorded. Okay, live as well as recorded, right? Okay, so this offer is valid till 16th August. You can just use the code Freedom15 to avail this offer. And the new GATE live batch, I'll update you. New GATE live batch. Okay, 17th August. New GATE live batch is going to be live on 17th August. Okay, the new GATE live batch, 17th August. Right, done. Okay, this is what is the important updates for you. New GATE live batch will be on 17th August. Okay. Also, if you are still looking for a very quick revision for the upcoming AEE Genco Transco Discoms examination and you want a crash course, okay, the recorded crash course, okay, you can still purchase it and you can use the benefit of that Independence Day offer also. Okay, so this is the details of the course. So you can even think about this course, which will be a validity, different validities you can purchase. Okay, you can watch it for this much of time. You can watch it up to the coming exam as well as later also for if you are targeting other exams. Okay, so accordingly you can choose the validity 45 days, 3 months or 6 months. Accordingly pricing is mentioned and you can take the benefit of the Independence Day course. Okay, so the new GATE 2027 offline batch for electrical, EC will announce the batch date. Okay, it's going to start on August 10th. August 13th. There are slight modifications here. August 13th. Okay, and as well as the Telangana AEE course is going to start August 13th. Okay, it's going to start August 13th. The new offline course, okay, starts for both August 13th. Right? Okay, these are some crucial updates. That's it. Thank you. Okay, this is again the Telegram name I have mentioned. I've already shared the link in the chat box. You can join from there as well. Okay, thank you for your dedication. Thank you so much. I hope you enjoyed it. All the very best for your exam, and we'll bring up our team will bring up more sessions, most likely on around Tuesday. After 2 days you can expect a session on power electronics. Okay, because all faculties are busy with both offline and online schedules. That is why I cannot confirm a date here, but mostly in 2 days. Okay, in 2 days you are going to get the power electronics, similar 50 sessions, 50 questions in one session, power electronics. And yeah, because I've not told you the exact time, you can just subscribe the channel. Because you'll be subscribed, you'll be aware about the sessions, you'll not miss it out. Okay, similarly other subjects will keep following, right? For the prices of batches, you can contact our numbers. Okay, you can just contact 95156 94053. They'll guide you the fees and the fee structure, everything in detail.